लोगों को बुला लो करके अपने अपने दोस्त बन गए।
Can be done up to you.
Okay, so good morning all and welcome to the SERB sponsored workshop last day. So I invite Dr. Neeraj Sharma sir to continue his talk. Okay, sir, please.
So today I am going to continue with the talk on the artificial intelligence and its application in biomedical engineering. So there are lot many applications possible in this domain. Not only in this domain, but in every domain we can find applications of the artificial intelligence and other related tools. There could be other related tools also which you can apply. You can do the lot of things by statistical analysis also. Just yesterday I have talked. You can also do the thing by these convolutions also, simple convolution principles. Then you can do the things by this artificial tools also. In artificial intelligence, it is the broad domain. You can go narrow down. You can find the fuzzy logics are also there. Fuzzy systems are also very capable. They have got their own domain and they have got their own applications when you are dealing with at the front of the artificial intelligence. So let me start now. So I will in this I am taking two applications. One is the on the development of the prosthetic limb that recently my student has worked on, and other application in the area of the image processing. Of course, image processing and signal processing, you can take any domain, but by and large the principle remains the same. So what is involved in intelligence? So what do we do with our intelligence? That is the main question. For example, normally use our intelligence to learn the thing, and whatever we have learned, want to then apply it to day-to-day routine. That is the intelligence. And of course, on this basis, we can define learning in 2-3 ways: supervised learning, unsupervised learning, and can also have associative memory like things. For example, the first lesson which we learn is A with apple, A for apple, B for boy. That is learning with the association. So associative memory has also a very good role to play once we are able to associate and learn. Even you can see that a child can recognize the handwriting very easily. My way of writing A will be different. Someone else writing A will be different, but still it is able to recognize. Okay. So same thing is with the intelligence in general. So intelligence, the role of intelligence is to based on the memory, whatever it has stored, it has learned with the help of the neuron to recognize and reproduce and classify the things. So different decision-making steps, manipulation steps, they can be performed with the help of intelligence. So ability to act based on the input data, analysis of the data, decision, and action as an output. So this is the very generalized concept of this. And normally this is the structure of the neurons. receive different inputs from this, and then strength of this synaptic junction. These are represented as a weight, one neuron to another neuron. This is the basically this is on this end the inputs are received. This is the processing part. Then the decision part is into this, and because of the massive parallelism, normally a neuron is connected with approximately 10 to the power 4 neurons. Is able to achieve very good ability of intelligence. So this is the acting potential moving with this, and its equivalent mathematical model, perceptron model that has been developed is this. These are the inputs, these are the weights, these depend on the synaptic junction, and some bias may be added to this, or threshold may be added. Then the function, activation function. So different activation functions are there. You can have threshold type functions, linear function, saturating line, sigmoidal function. So sigmoidal functions are the most popular functions that are used here, and different input can be directly is equal to f as a function wp plus b. So this is the main generalized equation that is implementable in perceptron network and perceptron neuron model and everything. Then you can have its in layers, put layer, hidden layer, maybe 1, 2, 3. Depending upon the complexity, more the number of the hidden layer, more complex it can handle direct. Basically, is the ability to handle the. Suppose I am taking this case of the 2-dimensional system. The ability to differentiate the domain in linearly separable boundary. That means which are representable by the straight line like equation. So then you can use the single layer of number. But in case if the boundaries are complex, the decision boundaries are complex, then you will have to go with the multi-layer type of neuron structures and systems. The more the multi-layer you add, more will be their property to learn. Now, and one more thing, for the ease and convention, we are having most of the time the feed-forward network system. But in actual practice, our brain may be having feedback type of networks also, which are sending out and feeding back, sending out and feeding back. That can make still with a lesser number of neurons to learn them. And this model is based on the sum of product model. You can also have product of sum model. It was proposed by Professor Kalra, was in IIT Kanpur, then later he joined as a director IIT Rajasthan or Jaipur. So that was proposed by him, and that is also a very good capacity. That will be the this is sum of product, that will be product of sums. That two models are popular, but conventionally, in most of the literature, you will find that this is the sum of product model, and these are the input vector, and n stand for the dimension. That is how many input it is receiving. Dimension means if two input vectors are there, 2 dimension. 3 dimension. You can have up to 100 or n number of input dimension. Accordingly, the complexity of the system will be there. More the number of inputs acting, more will be your dimensions. For example, if I am to model something, or if I am to work on something based on the input parameter, the number of input parameters decides the complexity. For example, right now, if I am sitting in this room and I have to plan the air conditioning system for this room, which has to operate automatically, then I have to work out what is the dimension, what is the sitting capacity, how much heat is generated through the light system, or what are the temperature variance. So the more the number of input parameters, more will be its dimension. If I am to analyze the ECG waveform, then accordingly I have to give the different inputs. How many lead? Total 12 lead configurations are there. And out of this 12 lead configuration, I have to label the different events. P wave, KORS complex, T wave, the deviation segments. Then what are the possible further deviations? So all things I will have to record and input. The more the number of input, more the number of parameter, more will be its dimension, and more will be the complexity. And this to handle this complexity, you will accordingly have to decide about the number of layers in the neural network. Deep learning network are nothing but more the number of layers, and the more as we have achieved more processing powers with the help of the multi-core systems. Easily 12 core, 20 cores are available. More number of GPU, graphical processing units. So all these features have given us added computational power to play with such type computationally expensive algorithm. Okay, but principally they remain the same. But by adding the number of layers, we are able to handle the more level of complexity, and we are able to generate better solutions with the iteration. We can go for the higher number of iterations so that nearly settling point is there. So broadly speaking, the artificial intelligence domain within this machine learning, deep learning are there. And within this, you can also include the further subsets of like fuzzy logic systems or any other system associative memory. So machine learning versus deep learning. What is the basic difference between these two? The difference is that I have taken over the input image, feature extraction has to be done manually. So where you are having lesser data and feature are defined, required to be defined by the user itself. It's mainly the user sometimes. Sometimes you don't want that your system to decide the features. You want that these are the features to be looked upon or given the more weight. Then definitely you will get better result when you are using this conventional technique. Then classification. Classifier are by and large the same in both the cases. And finally, the output. And in deep learning case, the only thing is that the feature learning section is merged with this your this deep learning layer itself. That is by the principle of convolution operation. Just like we have seen the convolution theorem yesterday. Thus, the convolution mask here also will able to after the convolution operation by the sliding window, it will be finding out some values which you can select as per the either by the max pooling or average pooling value. Okay, so that value will be deciding factor as a feature. So it will be finding out the feature by itself. So in that practice, it will do a lot of iterations on every image based on the data set bank. Accordingly, it will find out the values feature and accordingly will select automatically. Okay. So feature selection is now the part of this. So where you want to work blindly, you can use it. And one more thing nowadays, which we are available with, we can use with, we can concatenate the features also. That is, we can define some feature manually. We can find some feature by this layer. Then their combination can be done and feed it to the final decision-making layer, and you get the. So that is also possible. You can decide your feature also, and you can let the convolution network to find their feature also. Then by their combination, you can do it. And definitely, we have tried in 2-3. This came in 2-3 application. The results are better as compared to directly if you implement application or this application. Result improvement normally 4 to 5% improvement is there. If this is giving 80% result, this is also giving 80% result. But if you combine them, then the result may be 85, 86, 87. It can go up to max up to 87, 88 also.
Prior to output layer, we have to take.
Yeah, you can concatenate the features which you are getting from this. And one more thing, you might have heard about the very recent progressive attention network. Attention is all you need. Just like some of you might be in teaching line. So while examining the answer sheet, you directly visualize where the mistakes are. So that is the attention network. That is directly whatever the things is right, no problem. But wherever the things are odd, you can directly figure it out. Same is case when we analyze the easy signal. In easy signal, the normal patterns are going, but the moment some action is done, that there will be shift or change in the amplitude and frequency. So they can be directly find it out by the attention network. That yes, here the changes are to look for these changes, what they are telling. So accordingly, you can directly pick up them. So it will be time saving also. It will be directly focusing on the events where the change are taking place. So different variations are there, but attention network are the recent, and they have gained very good amount of good amount of attraction and applicability. So by and large, the tools are remains the same, but the moment you change it slightly, you will find that a lot of difference will be there. If you add the attention network directly to this type of system, then again another 3, 4, or 5% of improvement in classification accuracy will be there. So step by step, you can try one. You will find that. So that's what's the motive of my lecture today. Mainly, I wanted to tell you when you are experimenting. First of all, if you process the thing with the raw data, you may achieve a result of a classification to 55 to 60%. Then, after cleaning the data, it may directly go up to another 20% level, which is substantial improvement. Your data is pre-processed well, then the results will improve. In pre-processing, there's like a few things, baseline shifting you can add, then you can do the normalization, filtering some appropriate noises. 15 to 20% improvement. Then by properly selecting the feature selection and optimization is another issue. How you have selected the feature, if they are redundant feature or if, how they are behaving. So that will give you another improvement. Then concatenation or combination will another level of improvement will be there, 5-7%. Then if you certainly add some more tools like attention network or some optimizer to this, another 3, 4, 5% will. That is starting from this basic scheme, you can go achieving up to 95% and more plus, depending upon the data, how much data you are having, if it is properly labeled or not. Properly labeled data is another requirement in this field. Suppose if I'm showing the figure of something else and asking the child to learn something else, so he will learn something different thing. So proper defined uh, data and learning method should be properly. So proper definition should be there. That is, if I'm to make him to learn how many types of chair could be possible, I must show him that these are the possibility. Then he will be able to recognize on his own. Okay. So data selection for learning and training is another first primary importance of the requirement when you are working with the artificial intelligence tool. If you have not presented the data very well, then these tools will be of no use. Then second requirement is the proper selection of the feature. If you don't know much about the feature, you can rely on directly on deep learning type of method. But if you know something, you have a good fair idea that these are the prominent feature while working with this data, maybe signal data, image data, or any other data. It may be a stock market data also. Then you specifically work with the feature. That these are the feature which you want. They must be included in your algorithm. And of course, concatenation, attention, so all these things you can go on step by step adding. That will definitely improve your outcome. Okay. So, role of the optimization technique. What optimization is where up to what point we are supposed to make our system trained. Optimization can be applied in feature selection also. You can select the features optimally simply because whenever you are selecting any set of features, definitely one feature, you can start from the one or two features, then you can go on adding the feature. Feature means just if I am to feature selection is very important role. Suppose I am to sort some apples. How many type of apples could be there? There could be different variety, from red apple to green apple to the different type of shapes of the apples could be different. Their color could be different. So from that point of view, I have to decide how much minimum feature will be able to define this fruit correctly, how we can differentiate it. Similarly, if I am to select a student to work with me on some project, I will have to specify. First of all, I have to specify whether an undergraduate student is required or a postgraduate student is required. What will be his discipline? It may be electronics, it may be computer engineering, it may be information technology, but then what type of languages he is supposed to know? The better the feature I mark, better candidate I will be able to select, or whatever the lot is available, out of that, the better choice can be. What programming languages, what programming skills may be required, and how, what I am expecting from him. If he is required to be good in logical skills, if he is required to be analytical skill or programming skills, what I am expecting from him. That can be defined directly. Then what grade band I am looking for. So these are nothing but the features, feature in the dimension and dimension. So more the feature, more will be your computational load at the same time. So feature are required to be optimized accordingly. So optimal selection of the feature plays an important role. So optimization will definitely fuse up with your algorithm more often whenever required. So, and this will definitely lead to improvement in the outcome. Up to what point I am to make the system learn? If it is over trained or under trained, few terms are there, but of course you can always set the learning target that this is my learning target, this is the error of the surfaces which I am expecting up to this point. So genetic algorithm based algorithms could be there, particle swarm optimization could be there. So at this stage, the selection of this also plays an important role. Both are bioinspired optimization algorithm. For example, in genetic algorithm, the concept is the survival of the fittest. That is, whosoever is the best in your class, I can select him and ask him to work on a problem. Or that is the genetic algorithm. The second approach is I can make groups of you people and ask you to collectively use your intelligence to solve a problem. So in which you are going to expect the better result. In the second case, when you are working in a group, different skills, ability gets combined and work. So this is practically tried on the optimization algorithm also. PSO performs better than genetic algorithm. So we have practically tried different versions of PSO. We have, one paper is there of my PSO itself. Adaptive jump strategy was designed there. So you can also try different versions of this. So optimization algorithm and its selection also plays a role simply because our idea or main concept is to optimize the thing such that we are able to achieve the global minima. So that your algorithm doesn't settle down premature, else it will be of no use to going with it. So just to give you an idea, I've selected some of the this, you can say that optimizations problems. These are some of the standard optimization functions. So whenever you want to fuse anyone with your, you can try it on your block of optimization. That will tell you. So this is ACLE function. You can control the dimension. It is having multiple minimas before it leads to the global minima. Here this is egg holder type function. Multiple again minima. So it may possible that depending upon the dimension, your algo or problem may get stuck up at some level. But ultimately you want to reach to the global minimum. Same is again the older table. Different minima, the different operations are this one. Then uh, uh, the last one are your two function, ripple function and holder. So all these functions are there available, and these are there mathematical. Accordingly, take the dimension and use them. So these are the standard test functions. Here is spherical test function is multi-dimensional. It could be two-dimension to multi-dimension. Same is the Eclipse function, distinction function. Distinction function is directly available as a function in MATLAB. If you are using MATLAB, this function will be available. These, of course, you will have to write the equation and test your algorithm. So accordingly, you will be able to know whether your algorithm is reaching the global minima point or not. So optimization, fusing will be there. You can always fuse for better results.
First function is available in MATLAB or all functions?
No. अभी हो सकता है ऐड कर दिया तो पता नहीं है.
Yes.
बट जो MATLAB में अवेलेबल है वो रेस्ट्रिक्शन फंक्शन इजीली मिलेगा. वो आप चेक करेंगे तो वो मिल जाएगा. बाकी की आपकी इक्वेशंस आपको यू विल हैव टू राइट देयर रोजनब्लॉक फंक्शन, स्क्वायर फंक्शन, एक्ले फंक्शन, restriction function. So you can write the message. These are available on the net. You will search what is that. The multiple dimensions minimas are there, and there is it is there very. The moment you increase the dimension, your algorithm may get stuck up at some distance. So you have to plan it accordingly so that it is able to reach the global minimum point, so that your results are optimal. So why you can see that if you give a problem, it may go up to 90% classification accuracy. Simply classifier is alone not going to work. If to improve the classification accuracy, you will have to add some. First of all, you will have to focus on the feature selection. Then you can add optimizer at the level of feature selection also. First feature selection, and then at the level of parameter training of the network which you are using. So two-stage workout you can carry out. So along with this, you can test your function which you have designed specifically. Either you can use directly the function available like G or PSO directly available in the some MATLAB or in a form, or you can coin your own function as per your requirement. So if you coin your own function, then you can test it against the standard function, how it is performing as compared to that. If it is performing better, or the performance in optimizer, how we test. Normally, if you're going to run a same algorithm, optimization algorithm for 10 times, then you will have to see how many times it is reaching closest to that. It may give every time some different solution, but still you will have to check how many times it is very close to that. It, out of 10, it may be performing 6 times, then we can consider it as a good candidate. 7 times, 8 times, 10 out of 10 may be very difficult, but still you can work it out. So a standalone computing system to classify. So this we have worked with this prosthetic device control for the foot movement. So this problem we have taken when one of my student who was QIP candidate, was a teacher in the was from Gadwal region. So we were in the process of formulating the problem. We thought of designing a prosthetic foot which is hill adaptive or terrain adaptive. Normally, the prosthetic foot which are available in the Indian market, we are having flat foot type of. So when you might have noticed that when you are coming down across a slope, the pressure is more on the toe side, and when you are moving up, the pressure is more on the hill side, and that cannot be adopted by the foot which is of fixed type. So that's why from here we designed this problem, and accordingly we worked on the system that is adaptable to the terrain itself. So terrain adaptive foot design was the problem which we proposed and worked on in this system. So this is how you can practically select the problem by carefully visualizing around. So he was from Garhwal region. Suddenly it came to our mind that we can work on this type of problem. These are the issues which are faced by the amputees in the hilly region. So now coming out to this tiny ML. Whenever you are designing a prosthetic device, which is a little bit artificially intelligent, the main requirement is that you need a system that is real-time responsive, which can work with your data inputs in real time and take the action in real time. That's why tiny ML type system, this which is available. Some modification we have carried out in this. So tiny ML means tiny machine learning algorithm. You can search it. You will be able to see on the net for the ankle foot prosthetic control. This problem we define and then work. So implementation steps. Tiny ML machine learning. First of all, we were required to collect the data on the different slopes, on level ground, up climb, down climb, stairs up, stairs down. So these are the 4 or 5 possible combinations that could be there. So we collected the data, trained the system, and accordingly designed the circuit. So human foot movement, the machine learning techniques, and design of the implementation of the tiny ML on Arduino Uno. All of you are familiar that Arduino Uno is the device that is very easily available at very modest cost also. Few thousands, few hundreds to few thousand, depending upon the type of the version. So in that, you embed your system, and that will act as a standalone controller. So here for this application, we use Arduino 33 BLE control. So prototype designing for controlling the foot movement, sagittal. So machine learning workflow. First of all, data set has to be there. Step I have already seen. Removing unwanted records. That is the data which we have recorded, but maybe containing some different sort of unwanted data, which or the data is not faithful recorded. Then we'll have to discard that. That is the initial step for collecting the data. Handling missing data, then scaling or normalization, assigning class labels, one, hot and cold, and training set and testing set. Out of this, we divide this into training set and testing set. It may be 70-30 ratio or 70-20-10 ratio or 80-20, whatever you want to select, you can do it or you can rotate it. And classify, modelization, and then retrain the model which has given the best accuracy. So we tried in this the different, before coming to this tiny ML, we tried this for the different machine learning approaches and then accordingly selected. So that is called as the ensemble approach. So ensembled approach is also working well in some of the cases. So tiny ML machine learning this can be embedded on the devices, used on the embedded devices, and can use for the particularly this is finding application in IoT and this type of area. So it is essentially a field of study that lies at the intersection of embedded system and machine learning that involves running complex model on ultra low powered microcontroller. Okay. So tiny ML enabling ML in microcontrollers. TensorFlow, right, is a lightweight ML library for mobile and embedded devices. So this you can use for this. We can integrate it with IMU sensor, different input outputs, process sensor. So for this application, we have used 3 type of sensor. We have used the pressure sensor also. We have used the acceleration gyroscopic sensor and EMG sensor also. So inputs have been integrated from these three main platforms: pressure sensor, EMG, and force myography or force sensor. So key idea is to express numeric computation graph operations and then TensorFlow like. Okay. So this is the TensorFlow block diagram. Okay. So training and deployment. CPU, GPU, and TPU, you can use it on any of the. So this is the history of the emergence of this, okay, regarding the different. So now these are the different gate cycles. Some of you may be working on in the area of the gate analysis and detection. So gate analysis is widely used for different applications. Here we have focused its application on the prosthetic device itself, design of the prosthetic device. But it can be applied to different domain for the analysis of the age-related system, diabetic foot-related system. So whenever there is some ailment or disorder, the gait of the person will change accordingly. So gait analysis. So who are working in the area of the biomechanics may be working in the gait analysis. How the different foods work. So double initial contact loading. So these are set mild stance, terminal stance, free swing, initial swing, mild swing, and then undo. So this is one complete gait cycle. So this is called as stride, stance, and swing states. So gait analysis plays significant vital role in assessment of human locomotion. It comprises of determination of the various parameters such as stance phase, swing phase, heel strike, and the human gait analysis can be carried out in two different ways. One is by the variable sensor, just like your gyroscope, EMG, force sensor, and that. Another is by the non-contact method, that is, you can record it by the visual cameras, so that and from that camera, frame to frame, you can work out how the gate is there. So that minimum two cameras will be required, one from the front end and one from the side end. So that can be used to capture this. The variable sensor-based devices placed on the subject feet, knee, and thigh. The gait analysis method based on variable sensor are gait dynamics, gait kinetics, electromyography, and sensor FMG force myography, hybrid approach. Their combinations can be tried. Okay. Applications are sports, rehabilitation, clinical diagnosis, and healthcare monitoring. Sometimes some braces are provided to the patients for the correction to see whether the exercising or the braces provided to this is giving the desired result after some time. You can, after a week training or 15 days training, and that can also be quantitatively assessed in case of the patient with the gait changes or gait abnormal. So these are the patterns which we have recorded. These are the patterns which we have recorded in our lab. So this is the gyroscopic axis, gyroscopic recording, and Z axis. You can see the different. So these are very rhythmic pattern for healthy individuals, but for amputees and for slip disc person or any patients with the knee torn out, the pattern will change. So what we do, we detected the EMG envelope so that it becomes magnitude independent. Normally, what you will have to do, otherwise the magnitude will play some role. It will depend upon the body weight sensor, how it feels like, what are the forces. So if you go with the envelope detection, the magnitude will become insignificant, and the main information is contained mainly in the hand. But where the forces are to be measured, there the magnitude will become important. So EMG envelope, then shank angular rate, time interval. So these are the average and smoothed waveform. You can see that very much metric waveforms are the same pattern which you may be recording for your PPG like system. Almost similar to that system recording. Then you can extract their feature using this system and calculate. So these are for the level ground when a person is walking on the level ground. Then ramp descent. This is the waveform for ramp descent. You can note down the change will be there. Then the shifting will be there. Location. Then ramp ascent. Then for stair ascent, for stair. So these are the different waveforms which are recorded for this. So this has been done through inertial measurement unit IMU sensor. These are the gyroscope. Then resultant acceleration for level ground. So these are again corresponding to the accelerometer sensor. You can see that. So why I was talking about the feature? Sorry. This pattern, gyroscopic, this for accelerometer, acceleration measurement. So you can see that the change in the patterns are there, which are easily differentiable even by the naked eye. The patterns which you can differentiate by the naked eye will definitely your AI tool will be able to do much better with respect to this. But AI has got the better capability as compared to the human eye. They can differentiate even the smallest minutest change that is possible. But you can see that these patterns are already visually differentiable. So it was not very difficult to work with this data and design it for implement it for the prosthetic foot design, which is terrain adaptive type. Then machine learning for terrain classification. Raw sensor data, training data, machine learning, handle prediction and model. Same way, you can implement it on most of the data. Steps will remain the same. That is training, evaluation, testing, and validation. So, application of ML in human foot movement classification. Dorsiflexion, flat foot, plantar flexion, inversion, flat foot, eversion, lateral, foot flat, maintain. All these motions can be picked up and classified very well. So accordingly, these are the signals recording corresponding to the this A pattern is corresponding to the flat foot, then B is corresponding to the dorsiflexion and plantar flexion. These are the waveforms. You can see and differentiate. Very well differentiable. Okay. This is corresponding to FMV data. Okay. Now this was for the actual embodied trial and testing phase. So where we pick the signal and train the model accordingly, testing data, feature evaluation, training data, feature extraction, machine learning, train, feature extraction, prediction. So feature extraction. So there is one thing which I've already told you, that feature selection, manual feature selection is useful when you are having you are in the initial phase of the working with your data. Initial phase means when you are having limited data and you are to start with, then you can define your own feature that these are the clearly distinguishable feature from the waveform. You can define them and use them. So that will be the first step, feature extraction. You can start with the 2, 3, or 5 or 6 features which are easily handleable by you manually. You can differentiate their values, statistical values, okay, and use them. So statistical, wavelet, or any feature you can implement in the first stage. So once you have done it, the feature selection in the first stage, then after that you can go with the complex algorithm. So controller used for implementing TinyML learning technique, DLE. So these are some technical features. You can search them on the net also. DLE, sensor, and IoT. So all these were integrated in one to acquire the data due to transmission, and that was done. Then these are the EMG sensors that we have used. This is the microwave sensor. This is the electrode here, and the microwave muscle sensor, which can be used for. Then FSR sensor, force sensor. It's a 402 sensor that is used for sensing the foot pressure. Then this was the design which we proposed for this one to control the spring. This is MR damper. MR is magneto-rheological damper. This magneto-rheological damper has the advantage that normally the damping systems are with the spring and dashpot-like mechanism. Here the dashpot is filled with some fluid, and that fluid is having fixed viscosity. In MR dampers, the damping coefficients can be controlled electrically. So what we were trying to do in this work, we were trying to control the damping of the foot as per the terrain adaptiveness by using this MR damping system. That is when that is the stiffness, just like the stiffness of the foot changes under different condition. Same thing will achieve with the help of this MR damper itself. So small damping, MR damping type mechanism was introduced, and this viscosity of this was controlled with the help of the inputs which are receiving from it, and accordingly, the terrain adaptive work was possible. So like this. Ankle foot processes controlled in sagittal plane, dorsiflexion, foot flat, and plantar plane. And this was the spring designed by using the leaf spring material. Leaf spring you might have seen in the vehicles. They are very flexible. They can bear load and easily come back to their shape. So simple strip-like mechanism with the motor to control its relative parameters. To model architecture and training, different positions we train in that. And these are the classification accuracies achieved using EMG for all these cases, classification and so on. So accuracy was 97.92. Then turn on the control. This is the process. EMG FSR sensor, IMU, load cell sensor, then machine learning model, pulse width control, MR damper, damping control, motor control, rotation, all this. So for the step for tiny ML implementation of this. This is the video complete. So this was control with the intent, but we have tried it on the empty also. Empty वाला भी इसमें video included नहीं है, वो दूसरे उसके साथ. So a 3-class pattern classification, EMG signal and OMG signal, FMG signal in the combination have been tried, and EMG signal output from the FMG signal. So now next topic which I am going to take will be slightly different from this which we have discussed. That is regarding the application to medical image processing. Okay. Some part of this I have covered in my previous class. So this is in continuation with that. So application of AI to medical image processing. So in this, I'm going to take about now segmentation and feature selection. For human, it is easy to recognize pattern. However, making a computer solve this problem is still a difficult task. That labeling, proper labeling, and event marking has to be done. Computer vision is the area deriving its fundamental component from pattern recognition and artificial intelligence. The segmentation is the one key step that find application in diagnosis radiotherapy treatment planning, and so on. And with this development in the areas of the sphere will directly continuously achieving very good results. Recently, I have seen that artificially intelligent radiotherapy treatment planning system have been implemented in the different hospitals. You go to the site of the Apollo Hospital Delhi, you will find that they are having AI-enabled radiotherapy. AI is directly, you can see that, playing a very crucial role in different spheres of life. So what is segmentation? So segmentation is the process of dividing the objects which are similar in nature, and these methods could be based on amplitude-based segmentation. So this I am talking from the feature point of view. When you have to work on the features itself, how the features will be selected different layer by layer. Then finally you can go to the convolution network, and apart from that you can work with the joint with the features that are specific in nature, jointly with the convolution network and the feature defined by you. If you find that these are the important features and must be included, then you can select them manually and concatenate them or add them with use them in addition to the features that have been calculated by the convolution neural network. Simply because in that you directly don't know on what type of feature it is working on and what factor it is giving the importance. Only at the outcome, final outcome, you know that this is. But to address that, one GradCam method is also there. That is the heat map like systems are also there, which can find out how your algorithm has moved, to which point it has given the importance. So amplitude-based method, segmentation-based method, region segmentation-based method, and method based on the textual feature. In medical, particularly, texture feature plays an important role. Like in case of liver, kidney, and other organs, you will find that the change in the textural property is the primary factor. There may not be any structural change, but there will be the change in the textural property of the organ. For example, in case of the liver texture becoming coarse, more coarser, then it is an indication of the hepatocellular carcinoma-like condition. So, coarseity plays an important role. So that we can design find by the texture. Texture means like the texture of the dot pattern on the wall that is used for the sound reverberation constant adjustment. That is the texture. This is the texture pattern. Here, the texture is plain. So texture means how the patterns are repeating themselves in the space. So clinical application of segmentation, diagnosis, treatment planning, clinical studies, and the feature we are expecting from this is the reliability, repeatability, robustness, and least dependency on the operator. When you have given it, it should be able to do it automatically on its own. Then the main medical imaging modality. These are the four imaging modalities. Accordingly, you can work with them. Then problem encountered in the segmentation. Firstly, different tissues may have very close gray level values. For example, normal tissue and humerus tissue, and they are required to be differentiated. Same is the case when doctor do the surgery also. He is also supposed to differentiate the normal tissue from the cancerous tissue. There also some they normally you can do it with the different color of lights also. In light, the texture of the cancerous tissue will be different, and that of the normal tissue will be different. So here you have to extract this information with respect to the imaging modality. Secondly, in ideal imaging conditions are never realized in practice, hence there can be always presence of the noise, artifact, blurring could be there, sensor-related noise could be there, partial volume artifact will always be present, presence of the other artifact could be there. Artifact we have dealt yesterday, so today we are going to take this from the angle edge-based segmentation, region-based segmentation. Edge means finding out the boundary or contour. So boundary or contouring of the tumor is also very important process in radiotherapy for delineating the targeted volume, which will be the target volume accordingly how the radiation will be planned from the different angles and how it has to be there. So contouring for edge will be the requirement will be there. Then region-based segmentation. Region-based segmentation will be on the basis of the similarity of the pixel. Normal pixels or tissues will be of the same texture and properties, and malignant or cancers will be of different properties. Method based on the texture, and this will be detecting the texture in the images. For detecting the texture, we can using different statistical model also. You can use the wavelet models also. Normally, statistical gray level Cochrane's matrix feature are the best suited for finding out the textures in the image. So model based segmentation and atlas based segmentation. Model and atlas means that is, for example, if I am studying an abdomen image, I can mark clearly the spine, and from the spine, I know that at this location, at this distance, this organ will be there, liver will be there, spleen will be there, kidneys will be there. So that is called as the atlas based segmentation technique. Okay, and the same is the case with the brain imaging also. And atlas based segmentation is very much reliable. To a physician, these are very much reliable simply because they know at what distance and what location the things will be find it out and studied. Now, amplitude-based segmentation, the first most segmentation or the first step which you can implement quickly will be the histogram-based segmentation. That is, you can define the pixel value between this to this will be belonging to one organ, this to this belonging to another. So you can select it from the background and kidney, liver, organ, whatever map you are studying, you can. For example, in case of brain images, it will be gray matter, white matter, the cerebrospinal fluid, brain tissues, altered brain tissue, it can be segmented. For doing this automatically, you can go to the histogram. So wherever the minima points are there, they will be the point of the segmentation. So this pixel belongs to one region. Minima is there, the next is there, next is there. You can accordingly apply to this, and you get the segmentation result. You can also see it in pseudo color. So edge-based segmentation, region-based segmentation. Edge means applying the d by dt operators like Laplacian operator. You can apply Kenny edge detector. You can apply. Okay, or by border tracing, Markov snake patterns could be there. Okay. And in region-based watershed region, any of the region-based technique can be applied. Lot many techniques are there directly available. You can apply any one of them. So these are the result of region-based and edge-based method. So this is the edge-based method. This is the result of the region-based. And texture-based method. When you are doing it in the region-based technique, the first most prime limitation that you may knowingly or unknowingly do is that in an image, you must know how many regions are possible. To click a photograph right now when I'm sitting, you can find out the background is there, television is there, this is one object, this is another, this is another. Still, if you want to do the segmentation, on this you can find out the text. If it could have been only black and white text, so only two regions were there on this board: black texture, white background. But it is now containing black and blue. So in color domain, you find that three segments are to be there corresponding to the blue text, black text, white background. So defining correctly the number of regions in an image an important challenging task. Suppose I have suppose I am having an abdomen ultrasound image or a CT image or MRI, any one of them. My task is to delineate or mark where the liver is located, where the kidneys are located, where the gallbladder is located, and where the spleens are located. So everything has to be marked on their places. And suppose I have marked clearly the liver now. And within the liver, I will like to know what is the normal region or there is any abnormal within that. Segmentation, that sub-segmentation has to be applied. So that is the real challenge when you are working with the waste technique. So now classification of the pixel belonging to the same class and extraction of the feature vector corresponding to each pixel. So feature vector will be I will be defining how we find it out depending upon the different properties. So now feature extraction and classification has been broadly dealt under the subject of the pattern recognition, and these three main approaches are there. Statistical approach, we have already discussed. There could be a 3x3 window, 5x5, 7x7, or 9x9, or any odd window you can take, and you can find out the statistical property around it. The larger the size of the window, better will be your statistical properties if you are going to find it out. So statistical properties. Now statistics could be first order statistics, second order statistics, or even higher order statistics or values are possible. That I will just tell you. First order statistics means this is a window. If I just do the average and compute the value, that will be the first order statistic. If only one pixels or one value is directly involved and I have computed its statistic, I can find out the mean values, standard deviations, and so on. So this is the first order statistic. But if I consider their combination, how many times 1 with 2 are there, then that will become the second order statistic. I can do it in this direction. I can do it in this direction, or this direction. Any direction in their combinations can be considered, and any combination. So this is a distance. One combination I can also 1 pixel apart combination. So this will formulate your gray level Cochrane's matrix. Just tell you about it. So statistical is to find out the statistical value like mean, mode, entropy, that is the central tendency of the data, and its deviation from the central point. Standard deviations, entropy, how many levels or various shifts are possible, kurtosis, fewness, homogeneity, cluster tendency. Lot many statistical features are possible on our data. You can compute them and find out where the differences are there. For example, if I'm studying the liver image, the normal liver statistics will be different, and when it has developed some disease, its texture has changed, then its statistics will be different. And there is one disease of the liver, that is hemangiomas. There the patterns still become more fine as compared to the normal pattern. There the fineness is increased. So any deviation in the texture can be studied with the help of these statistical, how these pixels are varying themselves in the spatial domain and how the texture is changing. So for that, you can directly rely on the statistical approaches. Then synthetic or structural approaches. Structural approaches are important when you're studying the structures and their orientation directly. Okay. Then third approach is your spectral approach. These are also very popular approach. These may include your Fourier spectrums, Fourier features, wavelet patterns. So whatever the things which can give you the spectral information. What is the spectra? Two things are there. One is your basic pixel value, that is the known as your uh, spatial domain relation. Another is the spectral domain relation. What is the spectrum of the colors or the spectrum of the image texture that is present, image texture that is present. You can use Fourier and wavelet. Two are the very popularly used modalities. You can say tools for finding out the spectral features. And statistical approach, these are the spatial frequencies and autocorrelation function. Statistical organized according to their placement spectrum. Just first order statistics, mean, standard deviation, smoothness, skewness, uniformity, entropy. You can add much more features, first order. Then second order, gray level, how the combinations are operating. So this we define by d theta. D means how many distance apart. So if it is 2 pixel apart, distance is the correlation, then distance will be 2 and theta will be 0 degree, 45 degree, 90 degree, 135. So with this 4, you will be able to find out all the features and forms. If it is 3 pixel apart, then we are considering a 3 pixel apart combination. So these features are called as the gray level Cochrane's matrix feature. So these can very well reveal any texture pattern. Can reveal very well any texture pattern. Apart from this, one more feature will be there, which I would like to recommend you to study. Different features. That is by the combination of the two row, their summation property and their difference property. This paper was referred to this paper. So this is a little bit 8 times faster as compared to this V-Jules's feature or GLCM feature. So that can also will give you a relation in between equivalent to that gray level Cochrane's matrix feature. So that also is very good implementable. Then you can find out the parameter out of this. Angular second movement, contrast, correlation, sum of square, inverse variance, entropy, homogeneity, cluster tendency. They are features now computed on second order statistics feature. That is the combination of 2 pixels. You can similarly consider combination of 3 pixels at a time also, but that will become very complex. Computational time will increase enormously. As a comparison between the above method, spectral frequency-based method are less efficient, while statistical method are particularly used for finding out random and pattern structure, and for complex pattern, synthetical and spectral methods gives the better result, and their combinations can always be tried. You can combine. You have a feature vector which is having statistical, spectral, as well as syntactical. So feature vector can be made as per your requirement. Tailor-made. It could be tailor-made, or simply you can concatenate any of these feature with your convolution network also, which is a blind feature blocks like arrangement to compute the features itself. And method based on the texture primitive segmentation and classification can be done using any neuro fuzzy network. So bidirectional associative memory, fuzzy clustering. So one method is semi-supervised method. Another method is your unsupervised method. So supervised methods are definitely giving you going to give you the better result, but where you are having limited data, there or the data which is not seen by you earlier, for example, when initially COVID data was not available, you could have done it directly with the fuzzy like clustering tools or fuzzy grouping tools for segmentation purpose to have this. So this was simply optimized by the simulated annealing. Simulated annealing is the phenomena optimized from the physics phenomena, that when a metal is heated to a certain temperature and then gradually cooled down, it forms grain-like structure, and these starts moving around them, and the structure is then very well, you can say that very good in shape and properties. So that process is called annealing. That process in physics is called annealing. So here we initially, same concept, we increase the temperature and go gradually cooling. Gradual cooling means allowing the grains of the clusters. In clustering also what we do, we have the different seeds in the different point in the image. Clustering is grouping, and particularly in the case if we don't know how many regions are possible, then what we can do, within this image we can have different seeds either placed at equidistance or placed randomly. This could be random seeding also. This could be placed at some equidistance also. Then this region will start growing. Growing in the this is technique is called as the region growing. This also comes under the category of the clustering. And in fuzzy clustering, we allow the overlapping clusters to be formed so that the cluster is having properties very similar. They can be allowed to slightly overlap. That is controlled by the fuzzy weaken factor. I will just tell you. So this will start growing. So different cluster will start growing. If two clusters become close, if they are very close to each other, then they will be merged into one. Else they will hold the separate identity. So in this way, your clustering algorithm will work. So there has to be defined an objective function by you for this. What is the objective function? Up to what point you will be allowed the thing and growing of the seed. In this case, automatically, how many regions are there? This problem will be solved. But it will also depend upon the few of the factors which has to be needed to be optimized. For that purpose, we added the simulated annealing so that the gradual growing of the clusters is there, similar to the growth in the metal. So that's why the results were better as compared to the classical fuzzy C-mean based clustering algorithm. C is the number of clusters here. So segmentation and classification of medical images using texture primitive bidirectional associative memory. In associative memory, we simply define if the input image feature extraction defined by the user, template of the feature vector, and the image classification and this. For example, here these are the few templates corresponding to the brain image, gray matter, white matter, and cerebrospinal fluid and corresponding to the tumor. And automatically it was able to classify. So, for example, corresponding to this section selected, this was the region segment. That is the user defined. That is, you can define just like a lookup table that this is the property I want to look in the whole of the image. Then wherever this property or feature vector will be there, corresponding to this or this similar region will be there, it will do the segmentation. Corresponding to this region, this is the segmentation. Corresponding to the template, this is the segmentation. Corresponding to this region. So this is directly doing it by associative memory. So this advantage is that it needs very less data or virtually no data for training. You can do it in one slice. It will automatically mark the same region in the different slices very quickly. So easily a standalone type system, very well defined, and if you are sufficiently or experiencely or the doctor is very well labeled that this region belongs to this, then this technique will work very well. That is through the bidirectional associative memory. Just like this segmentation, you can segment for one. So then fuzzy C-mean based algorithm. Okay. The algorithm provides methodology for fully automated segmentation, and this approach is based on unsupervised. Unsupervised means now you are not bothered about to label the data. It will on its own find the label. It will on its own do the data and find the segment, and finally you can look at the centroid vector that will give you information to which region it is belonging to and what is that region marked. So the approach is based on unsupervised segmentation of the pixels. The design algorithm is virtually training free and needs only few input parameters like initial temperature and cooling rate. And this we have tried for different applications and to standardize. Then methodology in present algorithm, uh, simple classical algorithm, fuzzy K-mean algorithm limitation has been tried to overcome. Here the limitation was only this that C has to be defined by the user. So here it automatically pick up that C value. Accordingly, this is model and simulated annealing has been modeled as graph search method. Graph search means graph search method and the number of clusters have been found adaptively using subtractive clustering. That is, you are still not bothered to find out how many number of regions will be there, the image which you are visualizing. Simulated annealing is the stochastic method for global optimization. These are physical analogy similar to annealing of metals, in which liquid metal is cooled at appropriate cooling rate, will reach absolute minimum energy state related to complete atomic ordering of the metal. If the liquid is cooled at a fast rate, the atom will reach a sub-optimal energy state. That means the grain size will be much better. SA was invented by Kirkpatrick in 83 and by Kelly in 1985. In most of high-dimensional complicated models, there are multiple maximas and minimas, and we must have a variety of tricks such as performance, search multiple time different conditions, so that we are able to achieve the state. So to achieve the best possible configuration, simulated annealing optimizer was used here. So this is the graph search method. Suppose here the different clusters are there. This is cluster 1, this is cluster 2, this is cluster 3. So if I'm finding out or working on this pixel, then it will be given sufficient energy so that it can jump here. Earlier, the energy is higher, so the jumping will be allowed to the nearest cluster. One cluster to another cluster, this cluster to this cluster. If energy is still higher, from here to here, the jumping may be allowed. But as gradually the energy is going on low, so the jumping will be from this to this to this only, but no jumping from this to this. And still afterward, it will not be allowed to move from its own cluster, then it will go on settling. So regarding the optimization algorithm, at this stage, now I can tell you there are two processes. One process is exploration. Basically, what is happening in optimization in multi-dimensional space? You are searching for the solution, possible solution in the space. For that, you will have to explore the whole space. That is, where could be the possible minima. Suppose it may be lying at this position, this position, this position. Out of this, one global minima may be there, or one global setting of the parameter will be there. That will give you the last result. For that, first step will be the exploration. I have explored that how many possible minimas are there in the search. It may be discontinuous search space also, and we are using these techniques. So discontinuity is not an issue. Non-linearity is not an issue. Okay. So exploration will be the first step. Then second step will be the exploitation. In the process of exploitation, I will now finally settling down or searching, settling around that and exploring that continuously, and finally the results are compared, and the best global minima is found. So in exploration process, my algorithm will be having high energy. in case of simulated, if I talk with respect to the simulated annealing, it will be having high energy and pixels will be allowed to move from one location to another location freely. But afterward, once they got their minimum location, then energy will be reduced every step, and then they will be allowed to settle down or exploit that further. That is similar to function like we do the coarse tuning, then we do the fine tuning. The first step can be correlated with coarse tuning, that you are forcefully able to find out what are the stations which my radio wants to do. Then there is a, after coarse tuning, there is a function for the fine tuning, that after that frequency you can slightly increase or decrease so that your fine tuning is there. The coarse tuning, fine tuning, then settle it down that this is the best result now. So initial temperature is kept high, then cooling rate, this can be selected. This is a parameter which is tunable by the user. Accordingly, it will gradually decrease the dependency such that for large value of T, system can occupy higher energy state as T goes to zero in iteration wise. Going to downhill, that is occupy the lower energy states. That movements will be restricted. The selection of the neighbor state, the method is by the graph search method. That when energy is higher, it can move freely, and goes down, it will be moving gradually down. At each iteration, the pixel allow probabilistic to the nearest cluster. The new cluster is accepted probabilistically depending upon the energy. These are two probabilities. This new clusters are accepted. If our energy is there, then change is accepted with the probability. Then this is the fuzzy clustering main objective function. This depends upon the number of pixels, 1 to n, total number of pixels in the image. Then 1 to c, number of the clusters. Then membership function mu ik. M is the fuzzification factor. How soft you are allowing the cluster. If this fuzzification factor is 1, this fuzzification factor can be from 1 to infinity. If this is 1, then this will be operating as k-mean segmentation algorithm or hard clustering. This algorithm will be operating as k-mean. That is the hard clustering. Value of m is 1. Normally, if it is infinite, then very wide clusters could be there, and small overlapping can be allowed. Here, this is the overlapping. This is the cluster. This is k-mean. If overlap is allowed, slide overlap is allowed, then this value may be around 1.5. If more overlap is allowed, then its value may be around 1.5. So if you go on increasing this, so this will allow the overlap to be there. Overlap means a pixel will be belonging to more than one cluster, one group at a time. Okay, so that is the role of the fuzzification factor, M. Normally, for medical images, you can select it values around 1.25 to 1.5. 1.25 will give you the compact cluster, 1.5 will slide more overlap. That is, it will be helpful in dealing with the partial volume artifact also when you are using fuzzy clustering for finding out the segmentation in different regions. Okay, so mu it is the membership function, M is the fuzzification factor, feature vector, and Vi is the ith cluster center in the centroid of it. C is the number of clusters. So this is the algorithm. Feature vector in 3-dimensional space. That is how many properties you are computing. That is feature vector means the properties like mean, standard deviation, entropy. The more the number of parameters you are adding, That is the n dimension. That is called as the dimension subspace. Then fuzzification factor Dij, distance between the ith cluster and the pixel in the center. Suppose this is the center. Coordinates are Vi. This is the pixel Pi, and the distance of this. If the pixel is more at the distance from the center, Vi, V1, V2, this is any pixel at this point, then we can compute the distance from this. Suppose this pixel is kth pixel. This will be D1k. This is 2. Then the distance from this will be V2. It will be having, if it is close to this, it will be having more membership in this cluster as compared to this cluster. So this will depend directly upon the interval between. So this will be 1 upon Di k. So D1k, and is corresponding to this, it will be 1 upon D2. In this way, if the overlap is there, then this pixel will be having multiple memberships. Suppose here the another cluster is there, that is C3 cluster is there, coordinated are V3. So if it is equidistant from both the two or slightly more or less, suppose it is at a distance of some distance is more and its distance is less, then based on this distance, it will be more belonging to this cluster than this. And the membership matrix U will be given in this way. X1, X22, Xn number of pixels, C1, C22, in number of cluster. Here the membership will be depending upon the distance. Suppose this belongs to C1 and C3 cluster. Suppose here the membership will be in C1 is 0.4, more close to C3, then in C3 it will be having 0.6 members. And total of the membership will be 1. It may be having another cluster will be there. Suppose I want to move where membership will be. And in case of hard clustering, this will be allowed to have membership on only one group. That is, it will be, if it is more close to C3, it will be having membership 1 here, for rest it will be 0. That will be the case of the hard clustering, belonging to one and one group. So this is the distance matrix. Here you can use Manhattan distance, or we have used Euclidean distance. That is the physical distance between the 2 points. Fuzzification factor 1.25, and fuzzy membership count, iteration count. Iteration count means when the membership stop changing. Ideally, it should be stopping where when any more change in the fuzzification matrix. And this value is called as the mu ik. This value is called as mu11. This value will be mu13, will be mu12, and so on. And it will be mu(n)3. Membership of nth pixel in third cluster. Membership of first pixel in first cluster. In this way, this membership matrix will be formulated. So accordingly, the parameters: initial temperature, cooling rate, cluster, center, can be find out. And stopping criteria could be, ideally it should be 0, but you can have some small value 0.0001, so that your algorithm converges. So if if your image is complex, more number of pixels are there, that is high resolution image is there, then you can have this small value. Else you can have 0 also as a stopping criteria, that when no more changes are possible. So this is the vector, the formula. Second is to determine the number of clusters. The practical clustering can be used here. And fuzzification matrix calculate the cluster centers. This is how the cluster centers are computed. That is the value of Vi with respect to. That means the group of pixels belonging to distance this cluster will decide centroid of it iteratively every time. By every iteration, new iteration orientation. And every time iteration V1 will be computed whatever the cluster centers. And this will be then used to compute the membership matrix. One from this. This will depend upon the distance. This distance is the distance between the data point and the cluster cell. So, what is required in this fuzzy clustering? That is the intercluster distance of the pixels or the similarity index of the pixels within a cluster should be, the cluster compactness should be very good. And intercluster distance should be maximum. This is intercluster distance and this is within clusters, intracluster. So we are to optimize these two parameters in fuzzy clustering algorithm. So this will be your computation of the energy. We are going to pass out in simulated annealing. This is computed in. Then based on this energy, you can find out for the state A and state B and compute this. Changes allowed, else no changes allowed. Stopping criteria. U1, the next iteration, and LS is the iteration count. So L plus 1 and this minus this. If it is less than this, stop. If the values become same, that means that no more changes are there, then you can stop at this point. So application in this for MRI, brain and CT and abdomen images. Original image, just you can have any image or set of image. So these are the segmentation. Segments have been found and this is shown in photo color at what could be the possible type of segmentation. Same is the case with the other brain image. Different segments along with the segments marked in the pseudo color. For this is for the thorax region. This region, you can see changes here. Sorry, this is the abdomen image. This is the abdomen image lever where the changes in textures are for the thorax. You can see very well the information hidden is also revealed. These are the Markov test patterns on which we have tested our algorithm. You can see the very close pattern. Within this, these patterns are embedded. You can embed some more very closer patterns, and we tried to differentiate it. These patterns are clearly differentiated and find it out by the test table. And these are the normal patterns. You can see that the average values across this have been kept intentionally same. These are called as the Markov pattern, but still it was able to differentiate it. And these was this average along the row and column was kept same, and the differentiation of two side by side. This. So have been find it out. So with this, and this is one recent work of our fuzzy C-mean application algorithm. This is regarding automated modified multi-objective fuzzy C-mean algorithm. That means instead of one objective function, now we have worked with the multiple objective function in the same fuzzy C-mean algorithm. And accordingly, we have tried to find out the fuzzy hypervolume compact and this different test patterns were there with along with the noise. Try to find out their segmentation possible along with the ground. So this is the different frontal planes on which this computing finding out. So we have used spectral noise in the ground truth image and try to find out that first of all without noise, then along with the noise added, try to find it out that whether it is able to find out the different number of patterns, 1, 2, 3, 4, 5. 5 clusters were there. Automatically, 5 clusters were filed out of R. So this is this. So with this, I can stop here. These are some of our publications in this area. So with this, thank you all for your patience listening. हो सकता है थोड़ा बहुत आप लोगों को क्योंकि टेक्निकल था थोड़ा टाइम इसमें to deal with the public clustering itself. Here, of percentages little bit I move faster. पहले आपका prosthetic device का भी था और इसका भी था तो for an different time. I have tried to. So first, you can have my email ID and you can email me also.
Yes, okay.
Use PNN.
Just do it.
Yeah.
And
Any problem thing. Basically, when you have to start from some point. Just pick up anyone algorithm or select something. Well, once you get the result, you automatically get to copy with it. Then you will be in condition to play with that. Right, compare. Even when you're communicating to some journal, it will be required that compare your results. Algorithm. Deep learning data input. अभी आज की डेट में क्या एडवांटेज है कि आप किसी भी फील्ड में डाटा सेट सर्च करेंगे आपको ये ऑनलाइन प्रोसेस डिफरेंट सोर्सेज का डाटा लीगल डाटा सफिशिएंट मिल जाए तो वो सर्च कर सकते हैं नेट पे कौन सा डाटा अवेलेबल है पर आजकल बहुत सारे डाटा बेसिस लीगल डाटा आप बताएंगे स्पेसिफिकली तो सर्च कर सकते हैं कोई सर्च करेंगे वही but if you are not having data set you can go for recording in the hospital and you can go in the psychiatry डायरेक्ट हो सकता है वहाँ का रियल डाटा लीजिए that is your requirement of your medical practitioner will be very much objective augmented. Then ethical clearance will also be. उससे पहले आप ऑनलाइन में एक काम नहीं कर सकते जिस फील्ड का अवेलेबल है तो यूज करके अपने एलिमेंट्स को ट्राई कर सकते हैं उसमें आप ट्राई कर सकते हो जब डिफरेंट प्रॉब्लम पे जाओगे आपका एल्गोरिथम then now you can shift to the disease modality so different disease if it is not available you have to record on your own और उसमें मेडिकल प्रैक्टिशनर से आपको प्रॉपर्ली सर्टिफिकेशन प्लस प्रैक्टिकल फीलिंग Come.
Any more doubt? Sir is outside. So if you have any doubt, then you may discuss. Sir, so, so thank you so much, sir, for your insightful discussion. Now, may I request Dr. Anurag sir to please felicitate Dr. Professor Neeraj Sharma sir to with the token of gratitude. Sir, please.
Thank you very much for
I will
joining.
definitely like to thank the organizers.
Thank you, sir. Now the tea is outside, so we'll join within a 10 minutes because next speaker is on the way. He's there. Okay.
Okay,
So come back.
okay, so after this, one more session is there from Dr. Amit Vishwakarma. Okay, so that will be also this continuation of this lecture, medical imaging. Maybe a little bit hands-on. So I think this MRI image. I think we discuss more about medical imaging. So far, we focus more about signals and all these things. So this was very helpful, sir. Thank you very much for giving this talk, and I hope it was more technical discussion more. So if you are going in that direction in medical imaging, I hope this lecture would be helpful for you. So we all, as a organizing from the organizing team, I thank you very much for joining us physically here. Okay, so we will be having a short break, tea break. After this, we will join. Okay, thank you. Sir.
मेरी अच्छी बुनाई है। That's fine.
हाँ नहीं, इधर 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 कहीं में आ जाओ, वो क्या पीछे वाइट बैकग्राउंड में अच्छा नहीं। ठीक है, अब
तू ही रुक जा 10 मिनट और।
हाँ सर, मैं ही हूँ सर आपके साथ।
तू ही रुक जा 10 मिनट और, मैं खत्म करवा के
भेजिए।
आता हूँ बेटो।
मुझे वो निकालेगा। पीछे 3 सामने ये उतरो सिग्नल।
अरे आना। एक बार पोस्टर
हमारा लैपटॉप लगेगा थोड़ा, हो जाएगा।
अच्छा, तो फिर सर क्योंकि
नहीं, पीपीटी चल जाएगी,
पीपीटी चल जाएगी,
उसमें देखो बिल्कुल।
क्योंकि लैपटॉप कनेक्ट करने में सर फिर सारा लॉगिन करना पड़ेगा
ठीक है,
से।
चलो हमें सब ने मना किया, बच्चा ज्यादा दूर हो जाएगा हमको, चलो थोड़ा हम प्रॉब्लम मुक्तांगन ही घुमाएंगे। तो मुक्तांगन इनको ऐसा कर रहा हूँ, वही 12 बजा है, तो इनको थोड़ा सा आर्मी करा के 1 बजे तक यहाँ से अगर इनको निकाल दो तो 3 बजे तक तो आ ही जाएंगे आराम से। 1 बजे तक इनको लंच का बोलता हूँ, 1 बजे तक लंच कर लीजिए सर आप।
या तो सर अभी हम 2 बजे लंच कर लेंगे यदि पॉसिबल, देख लीजिए
12 बजे,
क्योंकि अभी मुक्तांगन जाके 2 बजे तक आ सकते। अभी मुक्तांगन जाके 2 बजे तक आ सकते, मुक्तांगन से तो साथ में लंच हो जाएगा। हाँ सर, वही सब चीजें एकदम लास्ट में बैठा के एक दूसरा इवेंट पैरेलल आ रहा है।
दोनों ही कर दो, पहले एआई वाली करते हैं।
दोनों ही पेस्ट करके रख दो वहां पर,
अरे पेस्ट मत करो,
कॉपी।
हाँ ये मतलब थोड़ा सा
अच्छा,
लेक्चर नोट्स से।
तो आप पेन ड्राइव से ही
पेन
डायरेक्ट
ड्राइव से,
तो आप फिर पेन ड्राइव से ही डायरेक्ट चला लीजिए।
हाँ पेन ड्राइव से। और लेकिन इसका कोई एक टेक्निकल पर्सन भेजे थोड़ा।
किस चीज के लिए?
लैपटॉप में
लैपटॉप में
कोड वगैरह हैं,
क्या है, एक कोड पाइथन का एक प्रोग्राम है।
तो एक काम करते हैं ना सर, अभी आप लेक्चर यहाँ पर ले लीजिए, दूसरा लैपटॉप यहाँ पर रख लीजिए, इसको मैं स्क्रीन शेयर कर दूंगा, तो
हो
क्या होगा,
जाएगा।
ऑनलाइन वाले को नहीं दिखेगा बट ऑफलाइन को सबको दिख जाएगा। तो ऑनलाइन 1-2 लोग हैं, तो उनको स्किप कर
तो उनको
देंगे।
थोड़ा सा
तो एक काम करिए सर, का वाला लैपटॉप भी ले जाएंगे। उसमें ओपन करके रखिए, मैं ही कर दूंगा 2 मिनट।
या फिर अभी मत करो, अभी तो ये पढ़ाने में टाइम लग जाएगा ना। कितना
नहीं,
एक
मैं एक
एक
बार-
1.5 घंटे तो वैसे ही लगेगा।
फिर भी
ट्राई करो।
चले जाऊंगा सर, सबको बता के चले जाता हूँ, प्रिपरेशन करता हूँ। नहीं ठीक है उठते ही जाएगा वो। मत खींचो, वो वहां के तो जाएगा।
फिर ये हवा में लटक
इधर
या
रख
फिर
के-
इधर
ठीक।
या फिर इसमें सॉफ्टवेयर वगैरह इंस्टॉल करना है तो बोल।
कुछ नहीं सर, वेवेक्स ही करना रहता है, बाकी तो सर
पाइथन वो करना है, एक स्पाइडर का।
स्पाइडर के लिए ना कौन सा चाहिए
नहीं स्पाइडर हो जाता है।
सर, इसमें कनेक्ट कर देंगे,
करो
no
करो
issue। इसको बस ऑन कर लीजिए सर। इसको चार्जिंग लगेगी क्या सर?
लगेगी।
तो एक चार्जिंग चार्जर भी लगा दो, कोई दिक्कत नहीं, तो हो जाएगा कनेक्ट। इसको और उसको पहले कनेक्ट कर दो।
और मान लीजिए जैसे ये थोड़ा सा हैंग होता है बीच बीच में,
अच्छा।
तो रीस्टार्ट करना पड़े तो कोई प्रॉब्लम तो नहीं होगी?
नहीं।
कनेक्ट हो। ला उबंटू से कोई दिक्कत
नहीं,
होगी
नहीं,
ऐसा से?
कोई दिक्कत नहीं, इसीलिए मैं उसमें कुछ ज्यादा और कुछ नहीं करना चाह रहा हूँ। सिर्फ उसमें मैं सिर्फ आपको शेयरिंग दे रहा हूँ,
ओके।
क्योंकि बाकी सब चीज इसमें जो कनेक्टेड है वो है ही।
और ये वाईफाई पासवर्ड वगैरह मुझे बता दो, लगेगा थोड़ा सा।
बीच में कनेक्ट ही करते हैं ना। बताओ कौन सा आ रहा है, वो उस पे डिपेंड करता है। फिर ये कुछ प्रॉब्लम है क्या? कुछ
नहीं वो आएगा।
अच्छा। इस पे डिपेंड करता है।
तो हमारे इवेंट पिछले फ्राइडे से स्टार्ट हुआ है।
हाँ, नहीं पिछले फ्राइडे से। हाँ।
सैटरडे संडे तो ऑफ रहा।
नहीं सर, कंटिन्यू है। इसलिए आज हमारा लास्ट हेक्टिक डे हो गया है सर।
आ
आप
जाएगा।
ये है ना, ऑफिस मोबाइल है, ऑफिस मोबाइल का पासवर्ड लिख लीजिए आप, भेज दे देना।
इसमें तो ऑनलाइन वाला मैंने हटा दिया है, ठीक है, ऑनलाइन वाला हटा दिया है उनको, ताकि कंफ्यूजिंग ना हो।
अच्छा ठीक है ना। अब मैं नहीं, अभी मेरे को दे देना, मैं अपनी वैलिडिटी की प्रिपरेशन के हिसाब से उसको अरेंज करूंगा। ये मेरे को देना अभी सर, कैपिटल OM @ NetSec NET, स्मॉल में NET SEC, ठीक है। हाँ।
तो सर आप थोड़ा फोकस करिएगा उनको, थोड़ा सा प्रैक्टिकल वाला और थोड़ा ज्यादा देने का।
वही है ना, इसमें अब प्रोग्राम है तो वो इसीलिए हमने इसको कनेक्ट करवाया।
चलिए करा देना। नहीं
तो मैं क्या सोच रहा हूँ, इसमें सब ऑनलाइन चलेगा, बस ये उसमें लगा दूंगा तो शेयरिंग हो जाएगी। ऑनलाइन वालों
आप तो आप लोग इधर ही रहिएगा, कुछ टेक्निकल इशू ना हो।
सर को मैं बता जा रहा हूँ, थोड़ा सा वैलिडिटी के लिए उसमें लगूंगा, मेरे पास थोड़ी देर में आ जाऊंगा।
ललित को नहीं तो
कुछ
नहीं, अभी तो
दिक्कत नहीं है,
PPT
अभी PPT से ही
ठीक।
कराएंगे।
ओके
बस फिर है ना सर,
देखो,
इसको निकाल के उसमें लगाना है, कोई दिक्कत
इजी
नहीं।
रहता है यार ये।
हाँ, वही बोल रहा हूँ, और कुछ दिक्कत ही नहीं है, सिर्फ शेयरिंग करा
लेकिन प्रॉब्लम हुई तो तैयार रहता है।
नहीं हो तो मैं ही हूँ ऊपर, मतलब मैं यही हूँ।
मैं इन लोगों को सोच रहा हूँ स्पीकर्स को ना तो सही कर रहा हूँ, अभी ये छोड़
तो
दिया जाता हूँ।
स्टार्ट कराते हैं।
अरे हमारा भी टीए लगता
तो
है।
सर आप लेके जाइए फाइल, आप लेके चले जाइए, आप छोड़ने जा रहे हो तो उनको टाइम करा।
अरे नहीं,
करवा दो, ठीक है ना।
तो ठीक है, मैं ले लेता हूँ।
हेलो, हाँ सर, हाँ सर।
स्टार्ट करो फटाफट।
और सर मेरा सुनो,
PhD के
वो-
कौन से सर?
5 बजे का और 7 बजे की
अच्छा,
ट्रेन भी है रहता है।
एमटेक के लिए ना। मैं सर, मैं फोन लगा देता हूँ।
देखते हैं।
ठीक है सर, मैं बोलता हूँ। ओके सर, थैंक यू।
सर
And sir,
सवा एक पे लंच हो गया तो फिर फेलिसिटेशन कब से जब अभी जो अभी करके खत्म कर देंगे फिर सीधे वैलिडिक्शन तो अभी उसके बीच में कोई नहीं बट ये लास्ट खींच के अभी मैं बता दूंगा 2 मिनट वेट तो बस ये लास्ट क्लिक कर दूंगा ओके so please man so welcome all once again so now it's my immense pleasure to introduce our keynote speaker Dr. Amit Vishwakarma. Dr. Amit Vishwakarma received the BE degree from the Taxila Institute of Engineering and Technology, Jabalpur in 2011. The MTech degree from PDPM Indian Institute of Information Technology, Design and Manufacturing, Jabalpur in 2014. and the PhD degree from IIT Guwahati in 2019. He is currently a faculty member with the PDPM IIIT Jabalpur. He is an active IEEE and IET member. His current research interest includes the computer vision, sparse representation, signal processing, pattern recognition, machine learning, and deep learning. So this was just a brief bio of Dr. Amit Vishwakarma sir. Now may I request Dr. Anurag sir to please felicitate the Dr. Amit Vishwakarma sir. Then after that, I'll invite Amit Vishwakarma sir to deliver this talk. Sir, please. Sir, PPT कीजिए. Sir, please.
So good afternoon to all of you. So we will in this few hours we will see the basics of pattern recognition, so that you can develop your AI algorithm, and then at the end we will see one programming code in Python, which you for image segmentation. As the title of the event is related to healthcare, so we will do the one of the application that is medical image segmentation. Okay, nuclei image segmentation. So the content I am delivering is from this book. You can refer this book. This is very famous book of machine learning by Bishop. Name of the book is Pattern Recognition and Machine Learning. Okay, this is the name. So let's start with the first thing, the basic thing to understand the concept of machine learning. We know this curve fitting problem. Means what we have, if you see as a roughly, we have this green points, okay, and what we are doing, we have this green points and this sorry, blue points and green line, curve. So these blue points, so how we obtain this particular graph? Actually, these points, the blue points is obtained from the green points. Okay, how? See, in x direction, we have 0 to 1. 0 to 1 limit is there. And in y direction, we have the target values, t values. So in what our aim is in polynomial curve fitting, given any random value of x, any x value is given, you have to predict the value of t. Okay, that is the regression task we are doing there. So let's start. So what we did, we have this green curve because sinusoidal signal, basically one portion of the sinusoidal signal, and we took the 10 points randomly from limit 0 to 1. Okay, clear? Then what I did, I added some points, some random noise on these points. Okay, so that's why you see the points, blue points are not following the green curve. Correct now? And not exactly following. It's somewhere it is higher, somewhere it is lower. So to understand the basic of AI or machine learning, so we start with this curve fitting problem. Okay, so assume that these x, now you pay attention to the symbols. Okay, otherwise it will be very difficult to follow. We have this vector x, this capital bold X, which consists of how many points? X1 to Xn. Okay, so x1 to xn is what? In our case, how many blue points are there? If you count, there is 10. Correct now? So 10 points. So n value is 10. So we may frame the vector from this. You know, capital X is the 10 point where n is equals to 10. So similarly, what is the this bold T? Bold T represent the target. Okay, bold T is representing the target. This y-axis. So this y-axis, the values of the y-axis is given by T1 to Tn. Means x1 value, for x1 value corresponding target is T1. For x2 corresponding target is T2. For xn corresponding target is Tn. So given these things, now our objective is, given these n values, now I give you n plus 1 value, some extra value, and some additional value. For example, n plus 1th value. Then your target is to predict the t value. What that? Tn plus 1. And that is the target. So this is the means framework. So this problem, why we are saying this polynomial curve fitting? Because we have this polynomial curve. We have to fit this some kind of curve which can exactly represent the behavior of these points. Okay, that is the motive. So this, if you see, we have this t hat and x hat at the end, t hat and x hat, which basically represent x hat is some new value. Okay, x hat is some new value. T hat is the predicted target y. This is like that, means x, let's say years in x-axis, and y-axis is the price of the plot with the years. And we can assume this like this. So given some year, what will be the target of the plot in some particular colony or area? Okay, so we have now, because this is the theoretical concept, now we have to develop this in mathematical form so that I can convert this regression problem into program. Okay, I have to write some program to predict this thing. So one of the mathematical equation is this. So all of us know this equation basically. So polynomial equation is there. So see, x is known. X is known means what is the year. Okay. Now we want to find what is the price of for that particular plot for some for one any colony. So y is the price basically. Now only unknown thing is that w. W is the target here. And W basically consists of these vectors. If you see W0, W1, W2, W3, Wm, these are the vectors. Okay, these are the component of the vectors. So jointly we are saying this thing as so this W is basically consists of these values W0 to W. Okay, so collectively known as this W vector. So this is the framework. Now the question is how we find this W0, W1, W2, W3, W1. And that is the aim, to predict the value of y. So let's start with, because we don't know anything about W initially, so let's start with some random initiation of W. And just you take any random values of W, W0 to Wn, any random value, and you put and you calculate this 1.2 equation. What this 1.2 says, see, there is a difference. There is a difference of predicted, y is the predicted one. Y is the predicted, for example, if we are considering our example of plot price. So y is the price of the plot. Xn is the, in which year you are actually finding, predicting the plot price. And W is basically the vector, the unknown vector. This W is basically the we have to find actually, this W vector minus Tn. Tn is the Tn is the target for the given Tn is the plots for the given Tn is the price for the given plots. Okay, so predicted plot minus the actual plot price. Predicted plot price minus actual plot price, and you take the square and minimize this framework. This is this is the error actually. So what we want, this error should be minimum. This error should be minimum. So how we can do this minimization of this error? So let's see this plot, how this basically error. This plot actually shows the errors basically. So this is the, let's say, blue is the actual plot price. Okay, and let's say your red line shows the output given by your model. Okay, now how to frame this model we will see. So some random line you have drawn, just randomly, and in the plot you random. This random plot is there. So what is this error actually? This error is nothing but this, the difference between the perpendicular distance between this blue point and its projection on this point. Okay, this to this, add this value, then add this value, then add this value. Okay, so all of these values we have to add. So that's why we are doing this summation. Clear? So now next is, let's say you find, now our objective is to find that W which minimizes this sum of errors. Okay, that is the aim. So which W which give us the minimum value of error? W which gives us the minimum value of error, I will represent that W as a W star. Okay, just for making difference. Right? So let's start. So we have this equation. If we go back, this equation. Okay. So this equation is there. So M is the order of the polynomial. Okay. So now let's start. If we make the very simplest equation, where M is equals to 0. Okay. In this equation, if you put M is equals to 0, what you will get? Only this straight line. Okay, you don't see this green curve because it is used for generating these blue points. Correct. Now you only see the blue points and the red. Red one is the line which which is given by your model in a machine learning model. So this. So you can see in this first plot, when M is equals to 0, when my order is 0 for the polynomial, the straight line is there. And it is not effectively representing the data. Correct now? And now you can see it is not exactly represented. When you take M is equals to 1, so you can see it slightly modified, but it is not exactly represented. Correct? When you pick M is equals to 3, then you find that there is a more representation of the data as compared to M is equals to 0, M is equals to 1. What is M? M is the order. Okay. In this equation, we are just making more or more terms. And this equation. Okay. So when you pick M is equals to 9, very high order polynomial to represent this data, you find that we find that the model which we are developing is exactly representing or exactly following the blue points. Okay, so out of these 4 cases, first 2 cases, these 2 cases, this one and this one, is called is basically under we call it underfit. Machine learning model is underfit. Okay, for this particular case, this case where each point is followed by your model, this particular case will be said to be a overfit case. Okay, but for M is equals to 3, the points are well followed by a machine learning model. Okay, so it will be called as the proper model. Okay, so why we said that this one is the underfit, why this fourth one is the overfit? Because underfit means, let's say your nest blue point, this is the model has been developed. Okay, now I give you some new point, new blue circle, which is, let's say, somewhere here. Just see the cursor point. Okay, but you know that your red line is following just straightforward, and it is just a straight line. Okay, so whatever your location of the nest point, whether it is here, whether it is here, whether it is here, whether it is here, okay, in whichever location is there, the line is, it will not represent the data distribution. Similar case we can see from the second plot, this particular plot. But in third plot, you will find that if my data is little bit wider, let's say somewhere here, so exactly my error is somewhere little bit minimum as compared to the first two cases, right? But in fourth case, let's say my new data point is located somewhere here, okay, in this particular location. So how, in this case, what will happen? This blue, this green curve, basically the model, will not follow this particular one. And it is not necessary that it will follow. It may follow, may not follow. Okay, so better choice to make this particular configuration. Okay, so how you will decide which configuration is better? By using 1.2. You have to minimize this error, which the W which give you the minimum value of 1.2 will be the best W. Okay. And uh, this equation is, you can see, is very much followed by this fourth curve, but it is not. But if your new point somewhere, I give you new points, then the error for that new point will be large. Okay. In fourth case, the error is 0, approximately 0. But still, this is not a good model. Okay. Because the red curve will not know which is the location of the next point. It may be somewhere here, it may be somewhere here, it may be somewhere here, somewhere here. How it will know what is the location of the next point? Right? So that is the motivation. So there are three things: underfit, overfit, and optimal capacity model. So third one is the optimal capacity. Okay. So now just we are doing this some experimentation with the number of order in the x-axis and error in the y-axis. So what we can see, there are two phases: training and testing. 10 points which is given, 10 blue points which is used for training, and let's say some test points, it is used 5 or 6, something like that. 5 additional points. So we see that when our order of the polynomial is small, then error is large. Okay, training and test error. Now notice, always remember that we have to see the minimum of test. That is our final objective. The test error should be minimum. So when you exceed m order of the polynomial, you will find that both the error, training and testing. Now how we are doing training? You don't know. We select different values of W. Find the proper W. That is actually the training part. So if you see carefully, for m is equals to 3 to 7, we have both the errors are minimum. Correct? So now you can choose that particular m. So there are some choices. You can pick 3, you can pick 4, you can pick 5, 6, 7, but you don't pick 9 or 0, 1. That will be not a good choice for it. Okay? So now we have this curve fitting problem. So let's say these vectors are there. W is a vector. So in this study, what we actually doing, we are computing this W naught values for 9th order. When my order is 0, so obviously I will get 1.1 value. So this value, let's say, for some experiment, this particular experiment which I shown you, for this particular experiment, W naught is coming out to be 0.1. Just you see the value 0.1. When m is equals to 1, two values, two values are coming 0.82 and -1. When m is equals to 6, so actually four values are given, but I think fifth or sixth value will also come. This is some mistake is there in the book. For m is equals to 9, how many values? 10 values. 10 values of W. So notice one thing here. Now you see this particular plot. For m is equals to 6, both the errors are small, and the values for m is equals to 6 are also close to 0. See, as compared to m is equals to 9, when the values of the W vectors are far away from the 0. 1, 0, 4, 2, 4, 0, 0, so many big values. So from this particular table, if you notice, if you make somewhere m is equals to 9 values close to 0, if you make some intentionally you make m is equals to 9 and the values of W close to 0. So what actually happening? This may create a better model for m is equals to 9. So see how we can do this. What is the objective of m? M is equals to 6. You now know why we want to minimize the values of m is equals to 9 case, because m is equals to 6 case gives us less error. So I want to check what will happen when I took m is equals to 9 values and minimize that error. And that is the objective. Now our next target is to minimize this values of W naught so that I can make this closer to 0, and then I will see what will be the error, and a training error and test error. So for some, let's say in this particular thing, the importance of the data points are mentioned. What is the importance of the data points? Means number of training data. So when you have 15 number of points, 15 points only, number of samples to train your model is something like this. And the order is m is equals to 9. Notice here, m is equals to 9 order. Order is for the polynomial is 9. So for 15 points, the nature is something like this, the red curve. And when you increase the points, 100 points are there. Okay? Now data samples are 100. 100, I should say, 100 locations of different plot and price is given. Okay? In first case, 15 locations of plot and price is given. So for n is equals to 100, when the training data is more, you can see the nature is slightly different. But it is very well represented. Okay? So that's why we say that more number of points, more number of samples are there. So there are chances that your machine learning model may perform better. Okay? That is the remark from this experiment. Okay? So these are the just that configuration. So okay. Now next target is how to minimize this values of W's for m is equals to 9. That is our target. So what we are doing, we have this equation earlier, error equation. See this 1.2. So I have to modify this equation little bit by just including the prior. I am just including the prior. Let's say the prior is this lambda by 2 W, L2 norm of W vector. Okay? We all know the Euclidean norm, Euclidean distance of the W vector basically. So lambda by 2, lambda is the some constant which is known as regularization constant. Okay? Regularization constant. So what it does, earlier we are minimizing this particular value, this particular term. Now I added this term also. So it will, what it will do, it will minimize these values of W also. For m is equals to 9. We are all doing this for m is equals to 9. Okay? So this W is a Euclidean norm, basically the dot product of W transpose W vector. So it will give you something like that. Okay. So now let's see what will happen if we minimize this particular equation 1.4. Okay. So if you before that, let's see what will be the effect of the lambda values. What will be the impact of the lambda values on this error? Okay. So you see, when we taking the log lambda, because what we do actually, we not simply minimize this straightforward. We take the log and then minimize. That is the motive. So that's why this log lambda is there. So don't pay too much attention to the log, just to see the nature. When your log lambda value is -18, okay, log lambda is -18. You see, the nature of the red one is the model which is we are developing, in a polynomial curve actually. We are designing, so it well followed the data point. But when log lambda is 0, so we see that there is no, means it give you very basic, it is not representing the data very well. Okay, so first case is better. So that is the impact of the values of lambda. We have to pick the proper lambda. We cannot just randomly pick any lambda. So this thing, okay. So there are two concepts arises from this equation. So this particular equation is known as ridge regression. Okay, if you technically someone asks you what is ridge regression, then you have to explain like this. Okay, this equation is important. So ridge regression, in ridge regression, what we are doing, we are including this regularization term, which is the L2 norm of the W vector. Correct? So this. And there is some other terminologies also, but I will skip this because other things are there, because shrinkage methods are also. Why this is called shrinkage? Shrinkage because we are minimizing the values of W. We are bringing W close to 0. In this case, W is very high for M is equal to, you can see negative and positive direction. Both are very far from 0. So that's why it is called shrinkage. As name suggests, shrink means shrink something. So this equation is the ridge regression. Now, if you choose L1 regularization, okay, lambda by 2 W1, then this 1.4 will become lasso regression. Okay, so there is a two things, ridge regression and lasso regression. Okay. So now see, when for M is equals to 9 order, we have different values of log lambda, minus infinity, minus 18, 0, and so on. So you can see that when my log lambda value is minus infinity, these values are there for W. When my log lambda is minus 18, so these values are there, which are close to 0. See what happens if you apply this regularization. Now your earlier value, which is very high from the 0, now it is become very close to 0. And for log lambda, it is further very approximately 0. Okay, so that is the advantage. So that's why this log lambda minus 18, if you see here, is very well representing the data points. That is the reason, because we bring the W values close to 0. That's okay. So that is the two things: ridge regression and lasso regression. Two things now. If you know earlier, that is good. But if you don't know, now you know what is the ridge regression and lasso regression. Okay. So just some experiments to verify our study. Log lambda in x-axis, take the different values of log lambda and in x-axis and calculate the error, ERMS. ERMS, you can see that this test is performed to find the proper lambda, because we don't know what is lambda right now. So just to plot the error, training and test, and see for which log lambda case both the errors are small. So you can see that from I think minus 33 to minus 28 is sufficient. And we can pick any value in between. Okay, check. So this is the regression part. So now to understand the AI models, we have to know the probability theory also. You know? So just we will quickly we will see what are the important aspects of probability theory, which will be useful. So as you know, as the first statement says that in pattern recognition, the probability theory is the main concept, because lots of the machine learning models are based on the probability, you know, based on the probability. Okay, so we have this simple example. So I will just to cover this for understanding the Bayes theorem. We have two boxes, red box and blue box. So in red box, some fruits are there. Orange represented by this orange color, and this green basically represent the apples. Okay. In second box, we have different setting, 3 apples and 1 orange. So this is the configuration. Now the very common question, and now let's say we pick the red box. The probability of picking the red box is 0.4, and for blue box is 0.6. Okay, this is the probability. So some questions are there. What are the questions? So see, some questions are, the question is, first question is, what is the probability that selection procedure will pick an apple? Okay. Whatever box you pick, you have to tell us that what is the probability of picking of a apple, okay, irrespective of the box. Now, what is the next question that can arise? Given that we have selected an orange, you know, we have selected an orange. Now find the probability that the selected orange was from blue box, or from that or from red box. Clear? So these questions basically we solve using the Bayes theorem. Okay, so I will skip this part. Okay, now see, there is one thing that is called joint probability. Just for quick revision, we have these two rules of probability: sum rule and product rule. This sum rule says that if we have probability of two random variables x and y, joint, you know, joint probability distribution pxy, or simply you say probability, joint probability of x and y. If you sum this distribution over all the y, it will give you x. Okay, and the product rule says that when you have this joint distribution, so you can use this, it can be represented in terms of conditional distribution, p y given x or px. And what is the other formula? P of, anybody? P of x given y into p of y. So in two ways you can represent this product, right? So using this product rule, actually we can develop the Bayes theorem. You know, this is the framework for the Bayes theorem. Okay, now let's come back to this our box problem. So let's say probability of selecting a red box is 0.4, blue box is 0.6. Now this probability 1.16 to 1.19, what it says, probability of finding an apple, okay, the fruit is apple, given that the selected box is red. So we all can calculate this probability. That is not important right now. But the understanding of this conditional thing is that, conditional probability is that, finding the probability of an apple given that box is blue or box is red. Right? So we can find that, you can verify this thing. So now next thing is we can sum these probabilities also. So what is the first thing? If our sample space is common, box is red, box is red. So probability for apple and probability for orange, okay, will be equal to 1. And when similarly, when our box is blue, then probability for apple and probability for orange will be 1. And equation 1.21. Okay, so this. Now the question we arise says that, now ask that what is the probability of an apple? Picking an apple. So obviously, irrespective of any box. Now I'm not looking at the box. Okay, so this will be the probability. We can find this. So we will not spend too much time on this. It is just for introducing you the concept of conditional probability, conditional density. So we will use these things. All of us know, but just quick summarization of. So now the reverse question. Reverse question we can solve using the Bayes theorem. So what is the reverse question? Reverse question is that let's say fruit is orange. Fruit is orange. Now find the probability that box is red. So we can use this Bayes theorem to find the probability. Okay. So this is the utilization of Bayes theorem. So now we will see one algorithm which uses this concept, and that will be called as Bayes classifier. Bayes classifier. Okay. So I should that's the probability density. We have, let's say, density of some random variable x. So p of x a to b dx is this, and p of x is greater than equals to. These are the probability properties of the probability density function px. Okay. So there is another parameter that is called cumulative distribution. Okay, CDF. So it is the summation over minus infinity to some z px dx. Okay. So this is the probability density. This is the properties of the probability density also. It is also always greater than equals to 0, and the summation of px dx is equals to 1. Okay. These are the some common properties. Okay. Right now, equation these two equations 1.31 and 32 basically represent joint distribution is given. How we can find the marginal distribution? Just to sum over integration over y, it will give us px. And like in probability case, p joint distribution of xy will be pyx px. Okay. So this just we are converting the probability into density properties, and densities are there. So some expectation are there. So I will skip this particular part because it is not that much of expectation. Only thing is expectation is some kind of sample mean. Expectation is those who don't know the average of some function. Let's say some function fx is there, and under a probability distribution px. Okay, average of some function fx under a probability distribution px will be this equation is basically represent the expectation of the function. Okay, expectation of the function. When x is discrete, so obviously summation sign is there. When x is continuous, the same equation becomes the in summation sign become the integration. Okay, when x is continuous. Okay. So you can find that we are finding the expectation of fx here, but we can find the expectation of two variables also. Expectation of fxy, and xyz, xyzw, you can extend. So there are some properties. The important thing I will just explaining the variance property. This 1.39 basically the variance of function is expectation of the function square minus expectation of function and then take this. Okay. Similarly, variance of x. This is common variance we already studied from 10th, 11th. That is the variance. Variance of variable x is expectation of x square minus expectation of x, and then you take this square. Okay, so this means function you can find the expectation of function and expectation of x also. Okay, so only important property or concept is from this expectation thing is that covariance and variance. So what this covariance shows? Covariance is given by this equation. Expectation of x minus ex, okay, y minus ey. Ex is what? Ex is the mean of x. Ey is the mean of y. You take one value of x, subtract with the mean, multiplied with some one value of y, multiplied with the mean of y. Okay, then it will give. You store that value. Now you take the another x, another y, do the multiplication, store, another x, another y, do the multiplication, store. Okay, so it will give you some scalar quantity. Okay, so this is the covariance of two scalar variable x, y. Like if we have this x, y as a scalar variable, we can have the x, y as a vector also. We can extend this thing to vector. So in vector case, same equation. Take the x minus mean of x, y minus mean of y. Okay, and we find the covariance of it. If we solve right, because this is important, this covariance matrix. Okay. Let's say we have this x, right? X and y. 1, 2, y is, let's say, 3. X, another x variable, the variable is, let's say, minus 2. Y. This thing is. So what this expectation of x will be? क्या होगा? The mean 1 minus 2 minus 1 divided by minus 0.5 and 2 plus 3 1. So that is the x. Okay. So when I am saying x minus expectation of this equation 1.4 just above. So this vector minus this. Then this, now you have to find the expectation of 1. So this will be 0.5 and 2. So this minus this, then y minus y transpose minus. So you can do this directly. This minus this. Okay. So we'll get some, let's say, some value a1. This difference and this difference and product. So what you will get? You will get actually a matrix. Because what we are doing, transpose is there, so you will get some matrix, one matrix of size 2. This matrix multiplication. Now again is what? This is the first operation. This thing and this. Now A2 you will get. A2 we will get this minus this product. This is the vector. Difference is vector, and this minus. This is also a vector. Difference. So if you take the dot product, this vector and this, right? Just to put all these things in the equation. So you will get another 2 by 2. Now at the end, what we have to do, this expectation sign is nothing but covariance matrix y, or sometimes we represent it by this. So this will be nothing but A1 plus A2. How many components are there? 2 components. Okay. So what we will get? Now I hope this. Okay. So that is actually the covariance matrix. Now we can find the covariance of x itself, using this equation. Means just replace y with the x, and you will get the 2 by 2 matrix also. X is the x only. X is the 2 column, but x can take multiple values. So multiple. Vector variable that. Okay. So similarly, we can find the covariance of x with x also. Not necessary that we have to take y. We can find the X with X also. Right? So that is the why we actually discuss all these things, to just understand the concept of. Now we will see the Bayesian probabilities. Now, if I ask one question, that what is the probability that all the ice in Earth, in whatever exists in South Pole and North Pole, will melt? What is the probability of that event? Can we say that is the something probability is there? Yeah, it is difficult to say, not possible, because that event never happens. Right now, up to this point, it never happens to our knowledge. Correct now? So how to give the probability of that event? So we use in this type of probabilities, the related probabilities are given by the Bayesian probabilities. Okay, for the event which are never happened up to our existence, human existence. Okay, so what are the indicator? We have to give this probability. Now question is, give the probability. Give the probability for that. So how we can give that probability? We have to use some indicator. For example, we say that, okay, up to this year 2001, the water sea level in some country is this. Then in some another year is this. Another year is this. Another year is this. So we have to make some relation between, if sea level is increasing, what is the decrement in the ice? Okay, and using that relation, we have to give the probability. Understood now? But in flip coin, we flip the coin and get some probability. That event is already happened. So that's why there is a two type of probability. One is known as this classical or frequentist probability. Okay, which you can give the direct answer, you know, from the after the event. But in more general, the Bayesian probabilities are there, where you have to give the probability for the those events also which never happened, you know, up till now. Okay, so that is the difference. So now, just our previous problem is there. If you pay attention, PW is the prior probability. Okay, PW is the prior probability of the vector we are finding in regression. Okay, PW. PD given W, what is D? D is the targets. D is the target, the X values basically. Sorry, Y values. So basically the plot price. Plot price, and W is the vector we want to find. So you can find that this concept you can frame in probability also. So you can find the probability of the vector given that the targets is equals to probability of the target given a W multiplied by P by W divided by P. Okay, the same problem I converted, which we are solving using regression earlier. Okay, we are finding error now. So the same problem I converted into probability framework. Okay, means same question you can answer using the one error minimization and second using this. Okay, so two different algorithms you can make. This one, posteriori, is something like, as name suggests, event happens. Now you are asking the reverse question. Means posteriori, means I pick the fruit, that is apple. Now I am asking in which box I am picking the fruit. But the normal question is what? What is the probability that I pick the apple from the red box? That is a reverse thing. Event happens, that is the post, and posteriori means the probabilities which are you are asking after the events. And this term is basically known as likelihood term. P of D given W. That is the likelihood term. Okay. So these are some of the technical names. Okay. So one simple example, if I give you to just understand this thing, let's say if my algorithm is based on likelihood, my algorithm is based on likelihood problem. Okay, so I am giving some. I have two conditions: P of D given W and P of D given W. Okay, two conditions. And let's say this is W1 and this is W. Okay. Now I am saying that my question is which W you will pick. Whether you pick this particular configuration or you will pick this particular configuration. Okay. So if you are selecting, making a decision, now the question is find the proper W. Somebody gave us two options, W1 and W, only two options. Now we have to pick any one out of these two. So what is the criteria? One criteria is this. Just you compare which one is higher, which one is fixed max. Okay. And for example, this one is max. It's greater than P of D given W. Okay. So this will says that this type of algorithm where you are making your decision based on likelihood. So that will be known as maximum likelihood. Maximum likelihood. Next slide, please. Maximum likelihood. Because you are making your decision based on the maximum value of likelihood problem. This problem. But there is second algorithm also we can have. The second algorithm is this. Instead of using P of D given W, I can use this one. Why not? What is the wrong in this particular? P of W1 given D, you can make your decision using this option. Correct? No? There are two options. One is this, one is this. So you can make, okay, this one, let's say for this, the relation is this. For example, this for random experiment, this probability comes greater than this. Then I will say that this W1 vector is the better option compared. Okay. So that is the actually the application of this problem. Just to compare and make it. But one thing you notice in the second case, we have these two additional probabilities also, P of W and P of D. And these are the additional probabilities we have for making a decision. But when in the first case, P of D given W, in likelihood case, we have only likelihood only. We do not consider this P of W and P of D in that. Okay. So that's why this second approach is, first approach is faster because you can compute this and compare. But in second approach, P of W given D, if you are making your decision based on P of WD, posterior probability, then you have to find this PW and okay. So that is the main difference between these. So there are, you can basically, we developed two types of machine learning algorithm also. One is based on likelihood, one is based on posterior probability. So that actually called Bayes decision classifier, Bayes classifier, as named Bayes theorem. So the decision based on P of W given D, if you are making your decision based on that, so that classification will be Bayes classifier. Bayes classifier. Okay, that is the basic. Okay, so we just the same thing is there. Maximum likelihood estimation, estimating something from max. Okay, so now let's proceed with the some distributions before coming to the programming. One is simple, the maximum likelihood. Other one is base decision criteria. Technically, it is known as base decision criteria, or you can say base classifier. So now we will study the this Gaussian distribution. We already know, just for quick summarization, Gaussian distribution is represented by calligraphic n of vector variable x, which is given by 1 over 2 pi sigma square 1 by 2 e to the power 1 by 2 sigma square x. So what are these terms? Calligraphic n basically the density function. P. N is nothing but x is the scalar variable, and sigma is the basically the standard deviation. Sigma square becomes the variance. Mu is the mean, and that is the formula. Okay. So how this distribution actually look like? This distribution look like something like, mean is the this center point where the this we can see that the at mean we are having the maximum value of the density. Okay. So that is mean and mode. All of us know the mode now, mode of any variable, same thing. So what is the mode of this particular picture? Can you tell? Mu. So in Gaussian distribution, the mode and mean is same. Right? So mean of this distribution is mu, and the variance of this distribution is sigma square. Now we have this, see, right now we are dealing with the scalar variable, but if you go in practical, if we see in practical life, where we have to do classification or something and data analytics, the x is not a scalar variable. X is basically the vector variable, which we have just taken the example for covariance matrix. 1, 2, 2, 3. This is two-dimensional, but it can be more than two also. So let's say dimension is d. For d-dimensional vector variable x, so it will be bold x, mu, mean of those vectors, and this sigma is nothing but the covariance matrix which we have computed. Okay. So the equation for the d-dimensional Gaussian distribution is 1.52. Okay, so just if you see, d is the dimension of the vector. We are finding the determinant of this covariance matrix sigma, these two straight lines, and taking the square root, that e to the power x minus mu transpose sigma inverse x minus. Okay, so I ask just for, I want your views that let's say for any 1x, what will be the value of this 1.5? Can anybody suggest? For 1x, let's say any some x is there. So we will start with this. What will be this quantity? Is it a vector, matrix, or a scalar? बताइए आप सजेस्ट करिए. ये क्वांटिटी क्या होगी? This one vector, this quantity, matrix, vector और scalar. आप बताओ. पिंक शर्ट में, पिंक टी शर्ट में, क्या क्या होगी इसके? आप यहाँ आ जाओ थोड़ा, आ जाओ आओ आओ. वेक्टर. आप बताओ. ये what will be this quantity? X minus mu vector. What will be this sigma inverse? Scalar. क्यों? अभी हमने किया ना, we solve one problem. Matrix मिला था ना, we obtained the matrix. So किसी मैट्रिक्स का इनवर्स भी क्या होगा? मैट्रिक्स होगा. So this will be also matrix. ठीक है? What will be this? X minus mu transpose vector. So what will be the minus half is the scalar. So we don't have to look at this. No? Just the multiplication. So what is the final? What will be the final thing? Is it vector, scalar, or matrix? Scalar. Okay. So e to the power some scalar, then 1 over 2 pi d by 2. This 1 over 2 pi d by 2 is a scalar. Obviously, it will be scalar. 1 by determinant of any matrix is scalar. Square root of that is scalar. So what we will get overall equation is scalar. So the meaning of we are doing all this exercise to understand that given any dimension of x is of any dimension, the density value, Gaussian density value for any d-dimensional vector will be a scalar. Okay, that is the motivation. This equation looks very big, but gives you the scalar value, only one value. But it comprises of so many things. Okay. So this we can see. If we this is the scalar variable. You pick any. If we pick any x, then the corresponding probability values are there. Density. How we computed these values? From this equation, 1.46. Okay, 1.46. X minus mu is the scalar. Sigma square is the scalar. So overall scalar, e to the power scalar, and this quantity is also scalar. So for scalar variable also you will get this scalar. So that is the that's why these blue points are drawn. Okay. So there is one concept is there. This 1.52 actually leads to some is the intermediate thing of some operation. Just for understanding what we are doing, if we take these multiple values, this value, this value, this value, this value, this value, all the blue point, and multiply those values. Okay? If we multiply those values, so we will get something like this: P of x given mu sigma square. P of x given mu. Now what we are doing, just simply multiplying these different values of this. The simple multiplication given. You can do this multiplication also. Okay. So now this is the Gaussian distribution. Just we have already see all these things. I will skip this particular part because it will be too much time taking. Now next is the model selection, because if we are interested in finding developing some good model, and let's say our data set is small, let's say 100 points are there in our data set. Okay, 100 plots are there and their corresponding price is given. That is the problem. So to train this in this small data of 100 instances, we can use the cross validation concept. So cross validation concept is out of 100 samples, first part we have to save it as a validation part. Okay, and next 3 part will be the training part. Okay, in the second, now we run the same algorithm. I will pick the first part for training, second part for testing, and this 2 second part for training, and same for other ones. So we are running our one single model 4 times on this conference. Okay, and at the end, what we will do, let's say we are finding the accuracy. So what we will do, we will sum all these things, sum all the accuracies and take the average, divided by 4 of them. Okay, so like in healthcare also we can do this thing. Healthcare data is there. So this cross validation we can perform. This is very famous technique. Many people uses if their data set is small. Okay, so this kind of approach is called one of the model selection. Model selection. So cross validation is one type of model selection. Okay, so this part I will skip, discuss of dimensionality. Okay, the decision theory, just I just converted. Now we will see how we can convert this problem into our medical or healthcare problem. So what we have to do, see this equation, if we pay attention to this 1.77, it shows that probability of the CK given x is the feature or variable given to us. Okay, CK is the class index, C0 or C1. K can be anything, it can be multi-class also. Okay, and it is given, it is using the Bayes theorem, we use this Bayes theorem and you obtain this 1.6. Okay, so P of CK given x, P of x given CK, P CK. Now we can use this formula to classify one medical problem. So let's see this problem. So I will directly come to that problem, otherwise it will take time. Okay. Now assume x is the we are classifying two things, whether the person is healthy or whether the person is suffering from cancer. It is, this example is taken from that book. So x is the person X-ray report. Now from X-ray report we are detecting that whether person is healthy or having some disease or not. So we are doing this classification. So what we have to find, first of all, if we use this 1.77, so X is the X-ray report, CK is the class, C0 for healthy, C1 for non-healthy, and PCK is the prior probabilities of the classes, and PX is the marginal probability. Okay, now notice here I have only one feature, which is X-ray image right now. Okay, now if I it is in our common sense also, it is not a good idea to make decision based on only X-ray report. We can incorporate some other features also. What are the other features we can incorporate? Let's say blood report of the patient. Okay, so what we in this equation, what we are doing, we are just modifying, see, XI and XB. XI is the X-ray image of the patient and XB represent the blood report. Okay, blood features of the patient. Now we are using these two features to make a decision whether the person is healthy or not. Okay, so what I did, I used the concept of conditional independence. It means to make this model simple, that X-ray image, result of X-ray image is nothing to do with the blood report. But practically that is not in relation. There are some relation, but we are assuming that X-ray report is completely different from the blood report. Okay, so that's why I factorize this conditional probability. Xi given Ck and Xb given C. Okay, so this is the conditional independence property we are using. So now we are making the decision of the class Xi, Xb, and now if we just means extend this equation, we will get something, this first term, and if we further solve this, if we just use the probability concept and solve this conditional probability, So I will get something like this: P of Ck xi, P of Ck xv given P of C. We can use this probability knowledge we have to use. So this is one type of algorithm that is called Gaussian naive Bayes algorithm. Because you are using the Bayes theorem for making a decision. Okay, Bayes theorem for making a decision, and Gaussian is because our features, we are considering these features as a continuous features. That's why Gaussian is there. And naive is what the reason for using this naive word is that because we are assuming that blood report is not independent of the X-ray report. And that's why this naive term is there. Okay, so that's why we say this algorithm is Gaussian naive Bayes model. And we can use this algorithm for classification. So how we can use we have to just do the same thing. What is P of Ck xi x? This comparison we have to make, and then P of, let's say, healthy class is C0, X-ray report, blood. And I found this probability using this formula 1.85, and then I will find this probability for the same sample. Now healthy, this is non-healthy. Xi. So now how to make decision? If this probability is high, then I will say person is healthy. If this probability is higher, then I will say person is having some problem. Okay. So that is the intuition. This is the way we make the decision based on the probability. Okay. I hope this is clear to all of you. Those who don't know, those who know, obviously it is just a quick revision. Okay. So we do regression, we do classification. Just for a quick summary, regression, in regression task, our aim is to predict some continuous variable. Okay, and in classification, the task is to predict some discrete label. That is the labels. Okay. So information theory, all these concepts are there. So I will skip this particular part. And now we will solve some programming. We will do some programming. So to do that programming, some basic information of Python I will give you, because how many of you are familiar with Python, are doing some experiments in Python? 4, 5, 6. So just quick summary of the Python so that all of us can understand. So that basic, it will not give you the complete knowledge about Python, but basic thing we will see. Okay. First of all, in any programming language, we have to use the functions. So that is the core of any programming language, defining functions or all this thing. So in Python also allows the arguments, keyword arguments, even argumentary list. These are the things. So it can also allow compound data types. List is one of the data types. We will see what is all these things. Lists are there. In list in Python, it is also known as arrays. And this can be indexed, spliced, and manipulated. Means you can modify the list. You can truncate the list or all this thing. Change the manipulation, change the values of the list, we can do. In Python, we have the general interpretation. Like addition sign is used for addition, subtraction is used for subtraction, multiplication, asterisk for multiplication, and this oblique is we can use for division. Okay, as the sign represent, we have to use the same straightforward functions. Quick and easy, obviously. Okay, so It is my suggestion to those who don't know. Python is easiest language to understand. You don't have to understand there is no need to understand C, C++ or MATLAB to understand. है ना? This is the very simple language. Okay. So more reference, if you want to see more detail about Python, just you go to the official website, python.org. Okay. So in programming language, there are two type of language, high level and low level. So Python is a high level language. Okay. So how to differentiate between low level and high level? High level is something that, as you can see from this particular graph, let's say this system is there. Okay, this system is there, some processor is there inside the system, and maybe we have the mobiles also. In mobile, there are some processor also. Okay, so now I gave you one. I written one program. Okay, I written one program, and I asked you to run this program in both the things, in this laptop as well as in mobile. So do you think it will execute in both the things, both the equipments? Cross compiler. So and compiler should understand the functionality of both the processors. Correct now? So means that's why the concept of high level language arises. Means the code which you can run should be able to run in different machines. That's why we use this compiler. Okay, so what we are doing here, source code is there, we write in Python, then compiler, what it does, it convert to the machine code so that machine can understand. Okay, what is your name? Anubhav? Huh? Chitragupta. Chitragupta, which mobile you are using? No, model, company name? A1. Okay. So, see, why I'm asking this question? Because the machine code for mobile and the machine code for, let's say, for laptop can be different. It can be different. But to run the same that source code in both the machine, this one and the mobile, I have to use some compiler. Okay, so that I can obtain the machine code which is understood by mobile as well as by the computer. Okay, that is the meaning of machine code. Machine code, as name suggests, understand by the machine. Now you give any input and run the program, it will give you. So that is the overall profile of the high level language. Because high level language, what happens? We directly write the things which is very well understood by us, like a plus b is equals to 3, something like that. But in machine code, it may be something different. So that is. So interpreting a high level language, there are two things. We can convert this source code into machine code. One is using compiler, one is using interpreter. Okay, two ways we can convert. So this is the flow for the interpreting a high level language. Okay. In compiler, what happens? Just convert the code at once and then execute. But in interpreter, there is an iterative process. Okay, iteratively, the source code is converted into the machine code. Okay. So this is very common operations are there, compiler, all these things I explained. So in let's start with the Python programming. 3.4.3 is there. So it shows that 3.4.3 is the version. Python 3.4.3 is the version. So what you do after this lecture, just you open command prompt in your system and just type Python. simple like this. Simple Python and enter. If Python is installed in your system, it will give you something like this. Okay, if it is not installed, it will give some error. Okay, so you can execute the program of Python using command prompt also. CMD, just type CMD in search box. So these are the basically the pictures where we running the program in command prompt. Okay, print hello world. So hello world. Print 2 plus 3 give you 5. Okay. Print hello world. So it obviously hello world will print. Print 2 plus 3 5. Print 2 plus 3. So you notice here one thing. If you give these inverted commas, double inverted commas, so the same thing will appear at the output. Okay, 2 plus 3, and the result of this 2 plus 3 is basically coming this as 5. Okay, so this way we actually write all this. Now hello. Now next thing is functions. So how to define any function? So I am defining one function which is def, def in short. Hello. Hello is the name of the function, and I have to execute then this blank brackets. Now I have to give the body of the function. We said that this is the body which will be executed if you call this function. So print hello, print computers are fun. So if you see now when I'm running, I have to invoke this function. Now I have to call this function. So what I will do hello and this blank this spaces, this brackets. So what it does, it execute the body which is printing hello. So hello will come, and computers are fun. So computers are okay. So up till now it is very simple, and nothing additional thing we have to do. Just make more complicated program. One complicated program is this, little complicated. DEF for function. Greet is the function name. Now you notice I mentioned the person name. In previous case I just keep it blank, but now I am mentioning one thing, argument person. Okay, so greet person, then hello person, how are you? So if we execute this function, how will the output come? So I have to invoke this function. Invoke means you have to call. We have to call this function. So greet, and let's say the person name is John. Okay, so John. So hello John, how are you? Understood this thing? So like this we can make a very simple function. Like if you replace John by Emily, so it will give some. Okay, so this thing. So these some basics are there, so I will not cover this. So one of the, let's say, complicated program, chaotic behavior means this means generating numbers between two numbers, some numbers between two numbers. That is the chaotic behavior. So what is the simple program? Def main is this brackets. Now what is the body of this function? Print this program illustrates a chaotic behave function. X evaluate input, enter a number between 0 and 1. For I in the instance, execute this equation, print X and so what your suggestions? What will be the output of this function if we execute? How many values we will get? 10 values. So we will get 10 values. Okay. So what will be the initial value of X? What will be the first value of X? Sure. 0 होगा क्या? It will be provided by the user. Because we are saying enter a number between 0 and. Okay. If and user enters 0, then 0 will be there. Okay. So same like those we have this again print functions. Same thing. Sorry, I repeated. Okay, so these are the 10 different values when I put enter a value 0.25. So these are the 10 values. Okay. So very simple programming language. So this programming language we generally actually use for making a AI models, machine learning models. So if you put 0.26 also, it will give you some these values. So you can, okay. So this is about functions. Functions are now covered. So one question is there. If you see, there are some mistakes while making. If I change this main is there, all of you can see this main is there. Now, if I replace this main by, let's say, not main, then I execute this, I invoke this function main, whether it will run or not. It will not run. Okay, because your function name is not main, but you are invoking the main. But if you mention not main, then what will happen? It will end. Okay. So don't. Those who know, they know all these things, but those who don't know, they should not make this mistake. Pay attention to the function. Now, if I write your name is Chitragupt. If I write Chitragupt in place of main and call Chitragupt, whether it will execute? Sure. It will execute. Okay? Remember this. Right? So some technical names are there which I will not cover because I have to explain one program also. So for loop, you can use the for loop for executing 10 different statements. If you want to execute this 10 times, so you can use for loop. Okay. So these four, this thing, this last line using for loop is equivalent to using this 10 times. Okay, that is the advantage of loop. Okay, so we can write this program, two different values. We can use this temp Fahrenheit to Celsius conversion, all this thing. Okay, and this thing you will see after this class. So many things are there, but it's difficult to cover. Okay, so only next important thing, now we know about the functions, some basic things. These are just used examples. Okay, so in Python we can perform the swapping also. Just one simple example. So xy, let's say x is equals to 1, y is equals to 3. So using this last statement, xy is equals to yx, you can swap the value. Yeah, we don't have to use third. There is no need to use third variable. Temporary variable we say use for swapping. So there is no. Okay. So now we will switch to the one medical image segmentation problem. Okay. Where I will use this Python program, one Python program, and okay, meanwhile the system is starting. Other things, see, just for meanwhile the system is starting. So one problem is there. We can let's see what will be the program for this code. One function is we have to write, and the principal is there as Mooldhan, the amount of money invested in dollars. APR is the rate. Output is we have to compute the investment after 10 years, and the relationship it is principal 1 plus APR. Okay. Now, what is the question? What is the value of the investment after 10 years in future? So if somebody asks you to write a program, MATLAB, Python program on this, so is this correct? Or if there is any modification required? Yeah, we are just using def and function is name. You can use your Chitragupta also as a name. Okay. So gap Chitragupta and the print function and principal, enter the principal value, enter the APR value. So 10 times execution. So I have to use for loop for 10 times the equation. We should know this mathematical relation. Otherwise, it is difficult to find. So principal is equals to principal multiplied by 1 plus APR. That is the basic principal formula. Okay. So it will give you the. So there are some programs. Not do this all these things. Okay. So meanwhile, if you are, meanwhile system is starting, so there are some programs for your own exercise. So just you check whether you are able to find, understand this program. One is program related to finding the number in the list. Another is the program for finding the reverse. Okay, all these operations are necessary used in data science. In data science, let's say somebody asks, just reverse the list and then perform the operation. Then you have to at least know these basic operations. चलो अब इसको थोड़ा सा मुझे हेल्प कर दो. इसमें एक पहले हाँ. आप लोगों को भूख कौन सी लग रही है? चित्र को इधर यही है ना IIIT NR है. अच्छा यहाँ से डिम हो जाएगा क्या? चलो चल जाए. आप लोग जब तक नहीं जैसे ही फिक्स हुआ ना तब रुको आपके लिए उसको कनेक्ट कर. ऑफिस मोबाइल को कनेक्ट करिए सर, आपको दिया था. Program. हम क्या करेंगे, हमको मेडिकल इमेज सेगमेंटेशन करना है. वी हैव टू डू मेडिकल इमेज सेगमेंटेशन. ठीक है. सो न्यूक्लियाई इमेज सेगमेंटेशन. कनेक्ट कब आ जाएगा ना एक. हाँ जब अब तुम कर दो. ठीक है.
देखो कहाँ दिखता है सर.
वहाँ दिख रहा है. हाँ चलो ठीक है कर दीजिए. ठीक है. ये दिस इज one to those who don't know, उबंटू ऑपरेटिंग सिस्टम, ठीक है। तो यहाँ से भी आप यू कैन कॉल एनी फंक्शन, लाइक से स्पाइडर मुझे यूज करना,
Big that is
हाँ हाँ। कितने लोग काम करते हो उबंटू में, आप सभी में से? सभी विंडोज but it give you some robustness towards viruses, ठीक है। तो देखो स्पाइडर है, आई मींस स्पाइडर आई एम टाइप किया एंड नाउ माय स्पाइडर सॉफ्टवेयर विल ओपन ना। और इसको रुको रुको हो जाएगा। It take times. So meanwhile, I will explain you the data set which we are looking. So I request you don't see my other file names. ठीक है? See, so I have this data science data set actually. So let's start with the how this data set is look like. So if you just I will okay, let's I will tell you from where I downloaded this. Okay, so this image is there. Can zoom. So this is the nuclei image of our body parts, basically human body parts. Okay, nuclei image. So why I'm saying these are nuclei, because let's say these are the. If you one example of nuclei I gave you, if we go to the blood test now, in the RBC there is one one nuclei is there, that is जो कोविड के टाइम बहुत कम हो जाता था, वो क्या था, कैसा? प्लेटलेट्स नहीं, कोविड के टाइम हम बोलते थे कि ये संख्या कम हो जाती है, प्लाज्मा, उसका एक टेक्निकल नेम है, वो मुझे याद ध्यान नहीं आ रहा है। लाइकोपिन होता ना, क्या होता है ल्यूको, हाँ हाँ लिम्फोसाइट। सो इन दिस डेटा सेट one of the lymphocyte nuclei images are also there. How these lymphocyte are look like, basically like this. ठीक है, ऐसे ही दिखते हैं, ठीक है। तो अब हमको उन्हीं का ही सेगमेंटेशन करना है। अब सेगमेंटेशन करने से नीड क्या है, क्यों कर रहे हैं? फर्स्ट ऑफ ऑल राइट, लेट्स से सम क्रॉस सेक्शन की इमेज इज गिवन टू यू, है ना, इमेज इज गिवन टू यू। नाउ यू वांट टू फाइंड, फर्स्ट ऑफ ऑल माय फर्स्ट क्वेश्चन इज identify, count the number of nuclei in this image. Okay, अब ये हैंग हो, ठीक है, इसको रीस्टार्ट करना पड़ेगा। निकालें इसको, एक मिनट आ गया। स्टार्ट करना, Okay, meanwhile, this will start. I will just explain the theoretical concept. So see, if we have any nuclei image, which consists of some nuclei, or let's say, for example, lymphocytes are there. So what we have to do, first of all, we have to first ask is how many count, what is the count of this lymphocyte in this particular concept of the image? Okay, what is the count and what is the size? Because what happens, these nuclei may change their size if the person is affected from something, can be cancer or something. Depending upon the size of this nuclei changing means it may become bigger or may become depending upon the distance. So normal size, we should know what is the normal size, and if the size is higher, so we have to identify that okay, this size is higher. Okay, so how we can identify? First of all, by looking at the normal look, and another way is do the segmentation. So this segmentation, this is the need. First of all, in count, we can detect if there is any nuclei present or not, and count them using segmentation, and then using some image processing algorithm that how many are there, like that, and then identifying the size of this nuclei. And after doing this, all these things, size is the important factor. Size is the very crucial factor for making a decision that person is having some problem or not. Okay. So now after doing this segmentation, then we will take the decision. So that is the motivation why we are doing all this. So in the data set, what is given? Background में ना YouTube इसको निकाल देते हैं, निकाल दें? जिससे कि थोड़ा सा हैंग नहीं होगा। इसकी शेयरिंग से भी डिले हो जाता है। चलो ठीक है, लगा ओके, चलो इसको मैं जैसे ही छोड़ता हूँ ना तो ठीक है। चलिए, तो लेट्स सी आवर डेटा सेट। So we have this training data. Okay. So if you just open any random folder, so you will see two folders. One is train and another one is image and mask. Okay. So this is the nuclei image. This is the original nuclei image. Okay, of something. So this is the nuclei image. Now, if you just precisely see the location of this nuclei, because that is important for understanding the mask. You know, these locations are there. You know? Okay. Now, if I go back, now you see the mask image. So we will start with this. Okay. Now you will see this mask actually contains those, the nuclei is highlighted by the white portion. Okay. So you see this switch, 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 switch. Okay. So these are the different, their mask for each of the nuclei, but they are represented in separate pictures. Okay, that is the only thing. Now, what we have to do in our Python program, first of all, we have to combine all these images to make a single image, which will show all the nuclei image in single image. Okay, nuclei mask, sorry, not image, nuclei mask image for this particular image. Okay, and do the repetition of the same, uh, for other images also, like this. Okay, if you go see, there is another nuclei image where nuclei is look like this. Now, if you see the mask of this, how the mask will look like, each nuclei represented by one mask. Okay, so this mask is just a binary, means where the nuclei exist, give the white portion to that particular region. That is the mask. So you can see if we have more nuclei, so more mask, like in this example. Okay, so now see the program. So so many nuclei images and their mask are given. You can write the name of the data set. This is the data science ball nuclei segmentation data set. From Kaggle you can download. Very small size data set, not too much. So let's run this let's first of all see this program, understand this program, and then I will run. So I will make it little bigger. There is tools. References. Actually, we are sharing this now. That's why I don't have direct control of. नहीं एक्चुअली क्या है वो शेयरिंग था ठीक है एक मिनट so meanwhile I will just open this spider also so just go to the terminal okay it will take some time okay so see I just give you the don't see the code just I give you the portion in which portion we are doing what. So first of all, there are some libraries in Python. If we see our lecture, previous some slides, so we are not using any packages. So, but in this case, we have to use some packages. So you can see I am using TensorFlow package, a NumPy package, all these different packages are there. Okay, first of all, fetch the package first. Okay, then what is the next task? Next is this is the thing which actually does two things. First is resize all the image. Let's say one image is size 256 by 256. Another image of size, let's say 512 by 512. Okay. So then what you have to do, you have to make all the images of same size before doing any of this. Okay, now this is spider is open. You can install this spider. Just type in Google install spider. Okay, the file will come. If you are using Ubuntu, then sh format file will come. No? Or normal Windows, just double click file will come. Okay, just you type spider. No need to install this complete anaconda. Okay, only spider is sufficient. Right? Thank God. Now it is fine. अभी ठीक है? दिख रहा? So just explaining the portion of different code. So these are the library, TensorFlow. TensorFlow, ये सब कैसे install करोगे? How you will install? I suggest you to install from Conda. है ना? Just you type in Google, those who don't know, Conda install TensorFlow. Okay, it will give you one command. एक कमांड आएगी, ठीक है? उस कमांड को उठा के कहां पे रखना पड़ेगा? ये ओपन करना, डायरेक्टली यहाँ पे टाइप कर देना, ठीक है? लेकिन अभी इस पे मत करना, इस पे करोगे तो ये स्पाइडर क्रैश हो जाएगा, ठीक है? तो इसलिए नया विंडो ओपन करना, यहाँ से न्यू आ जाएगा, न्यू टर्मिनल, फिर पेस्ट करके वो इंस्टॉल हो जाएगा, ठीक है? तो बेस्ट आपको ऐसे केरास, टेंसरफ्लो ये इंस्टॉल कर लें, ठीक है? ठीक, तो ये आपने इंस्टॉल किया सारा, टेंसरफ्लो से सारी लाइब्रेरी आ जाएगी मोस्ट प्रॉब्ली, आपको फिर अदर कोई लाइब्रेरी यूज इंस्टॉल करने की नीड नहीं होगी, ठीक है? यू कैन सी ना 8 और 7 लाइब्रेरीज आर देयर, बट इन टेंसरफ्लो इट विल गिव ऑल द लाइब्रेरीज, ठीक? सिंगल टेंसरफ्लो लेटेस्ट वर्जन, ठीक? इमेज विथ, अभी हमारी साइज, सारी इमेजेस की साइज आई हैव टू फिक्स 128, ठीक? 128 फिक्स करना है. 3 is representing the RGB channel. Okay, color image है, न्यूक्लियाई की कलर है, ठीक है? ट्रेन पाथ और टेस्ट पाथ देना है. जो हमारा डेटा सेट रहेगा, इट विल कम इन जिप फाइल, so you have to extract that file, and after extraction you have to save this program in same location. Okay, remember these locations error are very common in all the programming languages. Okay, then train IDs, basically the name. Train IDs basically representing the name. Then X train and Y train, these are basically what we are doing. You are making the X train is the training data, and Y representing the label. Okay, Y is the label. Like in our plot example, na, X is the plot and T is the price. So same thing here. Y is basically the price. Okay, but it is now in form of image instead of scalar value. Okay, so I will execute this program. So we are resizing this thing, resizing of image and the mask. We have 20 number of masks for one image. Now we are combining all those masks in single image. Okay, so print done. So up to 70% this will be done. Now I am actually using the unit model. So in unit model, I am using this convolutional neural network. Okay, convolutional neural network with these specific specification. If you interested, you can ask the question. Okay, I will explain. So we have this 16. 16 basically means filters. How many convolutional filters? Of size of filter is 3 by 3. ReLU activation function with dropout to minimize the overfitting. Okay. Similarly, second, 32 filters, size 3 by 3. 32 filters, size 3 by 3. 64 filters, size 3 by 3. 128 filters, size 3 by 3. 128 filters, size 256 filters, size 3. Okay, means the nature of this architecture is something like this. It's like a U. Starting from this, now go downward and then go upward. Okay, because what you want at the input there is an image, at the output you also want image. You don't want a scalar value because you want the mask of the. So these are the just simple configuration. Now this is the model development. Now after model, I have to use the Adam optimizer for optimization, binary cross entropy, because I have two class only. Whether the mask is available at that particular nuclei or not. Okay, binary cross entropy. Model summary, checkpoint is there to prevent the overfitting. This callback function I am using just to prevent the overfitting. Okay, predicts train. Okay, meanwhile we will run this program. Okay, let's run. So to run this program, what you have to do, there is some arrow sign is there, you can see this one. This one. So just enter. Just you click on that. So now you see this. We are executing now. Now the file is start executing. I make this font size bigger. Right. Difference option is there. You can increase the font size. Is this thing is slightly better? This particular portion. Okay, so see what we are doing. We are actually resizing and combining the different masks in one image. So it will take some time. So 670, depending upon the data set, it takes time. Okay. So these some information is there. You can see 223 I TensorFlow core platform. You can skip this. That is not. This is just a suggestions. Okay. Meanwhile, we will run this. See this program. I think. Okay. So this is the unit. Means starting with the less number of filters. 16 number of filters, then go downward, take 32 number of convolutional filter, then 64 number of filters, then 128. So as we go this way, this direction, so number of filters are increasing. But when you go upward, so when you going upward from down to top, so unit is there, so this way and this way. So now you will see. This is the, let's say this is the contraction path. We say that contraction path, and now the expansive path. Expansive 128, then 64, then 20, 32, and then 60. Okay, like we have to follow this symmetry. So callback for early stopping to prevent the overfitting. Results, model fit. This is the command used for execution, fitting the model. So I am using the validation split of 0.1, mean 10% samples are used for validation. Batch size 16, epoch 2. I make epoch 2 just for quick execution. And callback is used for so that I can stop the overfitting. Then predicts. Now see this thing, predicts train greater than 0.5, predicts value 0.5, predicts test 0.5. Okay, so some boundary I am making 0.5 because binary decision is there, na? So 0.5 is the boundary for making a decision. Yes, one. No, I'm training myself. Right now, training is not started. Right now, I'm just pre-processing the data. Only 40% samples are left. So you will see the training also. This is not a pre-trained model. Means pre-training means someone has developed model for something. Okay, some classification, for example. Now your task is to use your data set on that pre-trained model. Okay, that is the thing. But what happens, the problem with this type of approaches is that because your model is trained on some other data set, which may be close to your data set or which may be not close to your data set. Correct, na? So if it is not close, so there is a possibility that the performance may be moderate. Okay, so generally what we have to do for research publication, lots of people uses this pre-trained. Lots of people say that transfer learning, the same thing is there, same thing but different name. Pre-trained model, transfer learning, all this thing. But for starting purpose, for if you want to do research in this, so better to develop your own model, and then you compare whether it is better than the performance with the pre-trained on. You have to compare. We cannot directly say that our trained model will be better or this pre-trained model will be better, give the better result. We have to compare the performance. Okay, that is. Okay. So 83% has been done. So in this case, there is no pre-training. That's why I use see this model. I am framing all this thing I'm writing. See, this is my model actually. Building the model, build the model. Build the model and 89% has been done. Now we will see the training part, how this training will be done, and some results will be there too. Right. So data set name you mentioned written data science nuclei segmentation data set. It is available in Kaggle. So 2018 data science competition was there. Some competition was there for classification for image segmentation, and they mentioned the data set and organized the competition for this. Which model by which user will be better. There is a competition. So now we are resizing the images. So done. So now you see. So now let's start with this. So this is your one of the image from the nuclei image. This is your one of the image. Okay. So you can see the nuclei are there. This one. There are different types of nuclei. This is the original. Now what this portion does, this portion actually just representing the presence of the nuclei with the white portion. Understood this thing? Right? Just I am finding the location. Let's say this particular two nuclei are there, which are actually touching to each other. So you will see. Clear? Right? So just this portion actually finding the from the given image, just recover the or just to formulate the binary image that will be the mask. Okay. So now we started the training, and this thing actually explain you about the model. So how many total parameters are there? 19 lakhs some parameters are there. Okay. How many are trainable parameters? 19 lakhs 41,000 are trainable parameter and non-trainable. Like in our regression example, where we took the order na 10, correct? 10 values. So in practical case, you can see how many, instead of 10, 19 lakhs parameters are there, you have to find. Okay. So that is the difference between understanding something, some concept, and applying to this to reality, some application. Okay. So now if we just I will summarize this part. So this is visible now? All of you can see this print. So epoch 1/2. I provided only 2 epochs. So first epoch takes 38 executions. Okay, executions takes 46 seconds for running one epoch. The loss is 614. Accuracy is 76. Means 76 times algorithm is finding the exact location of the nuclei. Understood? That is the idea. Validation loss 47. Validation accuracy 79. Okay? Means if you give some new samples, new nuclei image, so 79 times it is finding the exact boundary of the nuclei. So which should be higher, which should be lower? So obviously, as name suggests, accuracy should be higher, validation accuracy should be higher, but as compared to accuracy and validation accuracy should be higher. It should give more preference, importance. Okay, validation accuracy. And loss is there. This loss is training loss, and this loss is validation loss. Okay, so remember that your validation loss, validation accuracy, training loss, training accuracy, all should be losses should be minimum, accuracy should be high. Okay, and there should not be too much difference between validation accuracy and training accuracy. So in second epoch, the same thing is there. If you see, loss is first is 61, now 33. Accuracy earlier 76. After second epoch, it improves to 85. Earlier we have validation loss 47. Now validation loss is 38. It decreases. Okay. And validation accuracy earlier we have 88. Right now, earlier we have 79. Right now 88. Okay. So it improves. So these things, this 19 by 19, 3 by 3, 3 by 3, these represent for the test case. Just if you see the test images, we already saw this. This is not test. This is the pre-processing. This is the nuclei image test, and what is the predicted by the model is this. And if you want to see in a color from, so you can see from the color. Okay. Another, is it visible now? Here, are you able to see the white dots? All of them. So these are the nuclei. These are the nuclei. Now, what is the prediction by the model is this. If you want to see in a more better way, better visualization, you can impose the colors. So with the colors, okay. Now notice here, this is the performance when I execute my algorithm only 2 times. two iterations I provided. है ना? If you notice here, one epoch, second epoch. Okay, but in practically originally this algorithm at least you have to run for 25 iterations. Okay, 25 iterations take too much time, then your whole T will be covered in this portion. So that's why I use only two. Okay, so if you want this code, I will send you. You just contact me. You can then try your own. So any question you have, you can ask. हाँ, ठीक है
सर ये सर्टिफिकेट ले आए ना ऊपर से सर, विष्णु सर आप इधर मैं बता देता हूँ। वैसे अरेंज कर देता हूँ मैं तो कल मैं बोल दिया सबसे पहले ठीक है आपको भी नाम पड़ेगा ठीक है मैं भी नाम पड़ेगा तो हाँ थ्री टू नाइन सेवन है सर उसको चेंज करना है 3297 है बोलो अभी तक सर फोन तो लोगों से बात करने के लिए बोलो वहाँ हम सब भीग के खड़े हैं हम लोग 5 मिनट से सर बोले चलो नहीं आएगा बोल रहा हूँ कपड़े भी ले जाऊँ बोलते वो हीरो का ले चलते हैं क्योंकि मैं तो ये पढ़ना है थोड़ा उसके हिसाब से जल्दी आता सर मैसेज कर दो सारे लोगों को भी आ जाए वैसे अब चालू करेंगे तब आएंगे 10 मिनट के लिए वैलिडेट सेशन इज गोइंग टू स्टार्ट फॉर
सर उसी के अंदर रख दिया है मैंने बैग में।
हाँ बैग के अंदर मूवमेंट हो रहा है बैग में सारा लैपटॉप भी रख लीजिए हाँ इसी में सर आप करके आइए वो तो कितनी देर में
जी
पूरा एक डाल देता हूँ। प्लान के अकॉर्डिंग पेपर तो पता है सॉरी सर आज उनका कैसे नहीं पता है ना सही है ना अभी तक तो नहीं बुलाओ कोई नहीं तो करता हूँ फिर आप बात करूँ
Okay. Esteemed guest, dear participants and organizers. Today make the culmination of the incredible journey, a 7 days AI and machine learning application in a healthcare workshop sponsored by SERB. It has been a week filled with the knowledge sharing, collaboration, and innovation. We are honored to have each and every one of you here today to celebrate the success of this workshop. I welcome our chief guest, Professor Neeraj Sharma, Professor IIT BHU, Dr. Siru Sharma ma'am, Associate Professor IIT BHU, Dr. Pradeep Kumar Sinha, patron of this workshop and Director and Vice Chancellor of IIIT NR, Professor Rajesh Ingle, Dean Academics, IIIT Naya Raipur, Professor Srinivasa KG, Dean R&I, IIIT Naya Raipur, Dr. Rajeshri Mahapatra, HOD EC, Dr. PP Paltani, HOD Science and Humanities, and Workshop Coordinator, Dr. Anurag Singh, and other faculty members. Before we proceed with the valedictory ceremony, I would like to take a moment to express our gratitude to all those who will made this workshop possible. Our heartfelt thanks go out to serve for this generous sponsorship, which enabled us to bring together experts in the field of AI and healthcare. To kick off our valedictory ceremony, I would like to invite Dr. Anurag Singh on the stage to provide a summary of a key takeaway and summary of this workshop. Sir, please.
Thank you, Mayank. Very good afternoon to everyone. respected chief guest of this session, Sir Neeraj sir and Thiru madam, our VC and Director P.K. Sinha sir, our Dean Academics Rajesh Single sir, Dean R&I Professor K.G. Srinivas, and our HODs Rajasi Mahapatra sir, HOD EC P.P. Paltani sir, HOD Science Humanities and Management, research scholars, and dear participants. I welcome you all to the valedictory session of this 7-day long workshop on AI and machine learning applications on healthcare. So today we came to an end to this 7-day session, and I hope this session was fruitful to everyone, and it catered at least up to some extent to all of your needs. So before starting this little summary of this session, I would like to first thank to the sponsorship which was provided by Science and Engineering Research Board SERB, Government of India, whose generous support in terms of this financial funding made us able to attract participants like you all from all over the country. And I can say, because we have only, I think, local candidates. If I see, only a couple of local candidates we are having, and more than 90% are from outside. And I feel happy to announce that we tick mark at least all the type of institution as a participant in our this workshop. We IITs, ISC, NITs, very good private institutions like VIT, Vellore Institute of Technology, many good private institutions also. So that's mainly because of this financial support given by SERB in terms of travel and all those things that made us able to attract participants like you all from all over the country. Okay, so if and also just I would like to emphasize that yes, as announced in the beginning or in the time of registration only, I just announced that we are having limited seats in this workshop, and we got immense number, I mean, like a numerous number of registration. I can say 50 plus registration we got at least for this limited number of, I think 25 seats we are having. That was they are provided from the SERB. So it was tough competition also to pick out of 50 how to make it 25, but at the end I can say I'm happy on our selection because you guys have been very enthusiastic and eager to learn new things, and that made actually this whole workshop quite fruitful. Okay, going back to summarize the events we covered so far in this workshop, we try to actually keep a balance between theoretical concepts and hands-on sessions, and I hope that balance we maintained because the workshop title actually that involves an application oriented. The topic was application oriented, that requires tools, theoretical understanding of AI and machine learning tools and their applications. So we covered it. If I recall in the beginning, Professor Pachauri, I think he covered the different applications of AI/ML, specifically in seizure detection, and glaucoma detection in 2-dimensional for images and all. Then we covered phonocardiograms like heart sound analysis by PK Jain from NIT Rourkela. Then core concepts of AI and machine learning like software tools, because until unless you are not knowing the tools, it will be difficult to apply them in any application. So for that we covered the session of basics of machine learning and deep learning by none other than our ex-faculties, Dr. Vivek Tiwari and Dr. Munin Doja. They covered the insight of ML and deep learning, and after that we conducted a hands-on session also, the programming tools and other things. And I hope you enjoyed that session, and that would able to connect that how to apply a tool on any applications. Later, many case studies also we have seen, just like Professor BK Singh from NIT Raipur, he covered a complete pipeline, for I think it was a lung sound analysis, if I remember, lung sound analysis, starting from how to record the sound and how to analyze it for various application or various anomaly detection. Later, sir, Neeraj Sharma sir and madam, they covered that MRI imaging and medical imaging, and that EMG part. So EMG part, like any amputee, if it is there, how that EMG signal could be helpful for that. So that session was very fruitful in that direction. That give specifically for those who are working in this biomedical signal analysis, that EMG analysis and how it can be combined or integrated with other biomedical signal like EEG and all. So that gave the new direction in that way. So I hope that that would be useful. Finally, that's Amit Viskarma sir from IIIT Jabalpur. He covered the programming. It was, I think, it was core programming he covered, specifically how to code in Python and all those things. So it was in short, if I say, we tried to cover each and every aspect. Obviously, 7 days also may not be sufficient to cover entire thing, but yes, we tried to cover most of the things, and I hope that extent possible we covered would be helpful to improve your research skills and would be helpful for you to take new journey in your research career. So I will not take much time. I will end this summarization here with a thank to my organizing team because they helped a lot. Mayank, Abhishek, and many other research scholars were indirectly involved. So I would like to thank them also. At the end, Director Sir has provided a lot of guidance in that. Our HODs have provided necessary support and direction wherever it was possible. So I'd stop here by thanking all of them. Over to you, Mayank, for carrying out this session further. Thank you.
Okay, thank you, Dr. Anurag sir, for the insightful summary. Your dedication to this workshop has been truly commendable. Now let's move on the next part of our program, where we would like to hear from the participants themselves. That is essential to understand your experience, thought, and feedback to continually improve and refine the future endeavor. So I request participant to give the feedback. It's free for you. It's the open thing. You, you may come here. Anybody, please feel free to express your view.
Help us to improve
For the future.
future better.
Yes, please.
Feedback. So we are taking it formal feedback. We are making Google form. We have calculated, but it's a live feedback. I think that would help a lot improving the perspective of workshop in future. So feel free to give any sort of feedback. Please.
Respected chair, respected directors. Sir, I'm Vivek Kumar Pandey from Birla Institute of Technology, Mesra, and I am a senior PhD scholar and SRF in that organization. And I'm also a part of artificial intelligence and machine learning domain in my research journey. And I have already have appeared in most of conferences, workshops, and it was pretty much new experience over here. I have learned many new things, and yeah, definitely not only for research aspects, not only for the technical aspects. I can learn multiple environmental approach as well with a new thought process, and how to find research in my regular circumstances, like how to get new things and how to collect a new approaches, research approach by our daily routine lifestyle. So that was pretty much new experience over here. And thanks to all this IIIT NR Raipur, and thanks to Dr. Sir, they give this opportunity, and definitely it was pretty much good for me. Thanks, Mayank and Abhishek sir too, Prakash as well. Prakash was too much great. Give a great exposure for this Chhattisgarh and give some new thought process for research work as well. That is the environmental era we can perform by using AI concept as well, and from here in this agriculture domain and these concepts. So thanks, Prakash. Thank you, sir. Thanks a lot.
Please come. Sir. Those who want to give the feedback in Hindi also be considered. No. Feel free.
Good afternoon, everyone. My name is R. Ravichandra. I am PhD research scholar of Anna University, Chennai, Tamil Nadu. Yeah, my name is R. Ravichandra. I'm full-time PhD research scholar of Anna University from Chennai, Tamil Nadu. I'm doing my PhD under the guidance of Dr. A. Chamundiswari Madam, who is working as a professor of, professor in CSE department, SSN College of Engineering, Chennai. Actually, my title is Authenticated Detection of Vulnerability Behavior of the Implanted Pacemaker. I did my coursework at SSN College of Engineering only. The courseworks are the biomedical equipment, applied medical instrumentation, and the data analytics and IoT. On this purpose, I scored a 7.5 CGPA, and I presented my confirmation presentation, seminar presentation. I got approval from the university to proceed further. Now I started writing paper on detection of arrhythmia classification, which means the cardiac arrhythmia classification, AI-based cardiac arrhythmia classification. Actually, I just want to share my experience on my traveling issues. When I started doing the literature survey about the cardiac arrhythmia diseases, I found lagging to find out the data sets. Only the PhysioNet, MIT BH data set only available, in which I could not be able to track all diseases which need to track out. Like the 16 types of the cardiac arrhythmias need to track out. That I was checking there over there. Then, second thing, yes, this is a very important point for me. When I started studying the literature survey for doing my paper work, I came to understand, very of late, I came to understand that AI tool and machine learning tools are the tools. It's a powerful tools. We are being the usage of that tool. We are the user of that tool. Unless knowing our core subject or our core application, our data set characteristics, and the principle and the property of the property of the data set, we could not move further. Unless knowing all those things, we cannot move further. As per my concern, AI tool and algorithms are 10% of our research. Am I correct, sir? Second, yes. I try to get the data set from doctors. Doctors, naturally, they are not in position to give the data set information, which means the digital level, digital data information, they are not able to provide us. That is one set of lacking. It is not possible. When I met one doctor who was very much interested to give me the data for the cardiac patients who are coming to him. But thing is, he is ready to give only the ECG papers and ENG papers. The graphical format only they are trying to give us. They're trying to give me, but it is not work for me for my research work. So obviously, I request all senior experts and the VC sir, I request you to provide such kind of data set freely available in open source. Okay, so then the classification of arrhythmia, it comes, there are 16 types of classifications available. One is the left bundle branch block, right bundle branch block, and the PVC, and bradycardio, tachycardio, and other arrhythmias. For example, if I want to find out the left branch block system means, I should have to verify the different set of ECG data, like L1, L2, and V1, V6, like that. But obviously, in PhysioNet, PhysioNet data set, they are providing only two options for me. One, the modified L2 data lead, and another one is option of the precordial leads. Either it could be the V1 or V2 or V6, like that. It is making me disappointed to move further on my research work, sir. That's it. This is the thing, this is the main point I just wanted to point out. And thank you so much to VC sir and Dr. Anurag Singh for giving me the great opportunity to participate in this great event, which would help. I strongly believe that this will help me to move further on my research work. Thank you. Thank you, sir.
Anyone If anybody want to give the candid feedback, just we can say. Okay, no issue. We'll provide the feedback from online. You may. Okay. So thank you participants for their candid feedback. Your input is crucial to shaping the future of workshop like this. Now it's time to recognize your hard work and dedication throughout this workshop. We will provide with the distribution of the certificate to all the participants. Certificates are not just a piece of paper. They are testament of your commitment to learning and growing in the field of AI and healthcare. So may I request our chief guest, Professor Neeraj Sharma sir and Dr. Siru Sharma ma'am to distribute certificate to our participants. Please, sir. Now I'll invite and I'll call the participant name. Sir, you may join. Pratibha Sahu. Jaya Banerjee. P. Alti. Elizabeth Vinita. Hem Hirwani. Mriganka Sekhar. No, sir, we arranged the serial wise. Gyandeep. Pandit Vivek Kumar Pandey. Vedi Velen. Mr. Desigan. Mr. Ravi Chandra. Mr. Hari Kishan. Devi Prasad Patnaik. Mr. Praveen Kumar. Naman. Sanjay Kumar Mahto. Suman Das. Mr. Manjit Singh Sonwan. Mr. Govinda Kumar. Mr. Kamal Narayan Sahu. Miss Preet Kaur. Mr. Prakash Sahu. Miss Vansika. Miss Lavanya Soni. And last, Chitragut Sahu. Okay. Thank you, sir. Please. Now it's time to distribute the certificate to our organizing committee. So may I request Professor Dr. Pradeep Kumar Sinha, sir, our Director and Vice Chancellor, to please come, sir, and please give. So the first name is Abhishek, sir. Abhishek Srivastav. Please. Now Upendra Agrawal, sir. And after that myself. Myself, Mayak Lawanchi. Now I'll call the volunteer name. So the first is, sir, please. First is Achanta. Satvik. नाम M कार्तिकेय. ठाकुर जयदीप सिंह. अनिकेतन. देवाशीष. यशराज. आयुष कुलकर्णी. आर्यन कुमार बघेल. आर शिवानी. and Mr. Vishnu Prasad Verma. Now in continuing of this, we would like to present the token of appreciation to our head of respective department who has generously shared their expertise and provide guidance throughout the learning experience. So may I request Director and VC Dr. Pradeep Kumar Sinha sir to provide the token of appreciation to them. So I request first Professor Rajesh English sir. So please come and take sir token of appreciation. Now Professor Srinivasan KG sir, HOD DSAI. So I request sir. Dr. Rajashree Mahapatra sir, HOD EC. Please come sir. Dr. PP Paltani, HOD Science and Humanities and Management. Please come sir. And at last, our workshop coordinator, Dr. Anurag Singh sir. So please come sir and take the token of gratitude. So thank you, sir. So thank you all for your invaluable contribution. Now we have the honor of listening to our chief guest who has generously joined us today to share their insights. So I would like to invite our chief guest, Professor Neeraj Sharma sir, to come on the stage and please share some views, sir. Please, sir.
Very good evening to all of you. And first of all, thanks to Dr. Anurag and thanks to the heads of the departments present here, Professor Sinha, the Director of Vice Chancellor and Director of IIIT NR Raipur, and all the participants who are here. I welcome you and for this valedictory function. So it's my honor to give an address to you on the valedictory function. So as the theme was AI and its application in the healthcare. So regarding this, I can tell you from my experience that in roughly in '89, I got an opportunity first to go to CDT Mohali. By that time, the CDEC was earlier named by the CDT Mohali. And I was fortunate to meet Professor R.S. Khanpur. I think you might have gone through his book, Handbook of Biomedical Engineering. So that was my first orientation. Being my background was electrical engineering and then instrumentation engineering. So that was my first chance to get close opportunity to the biomedical engineering area. From there, I got the orientation. So it was almost, you can say that 25 years back. So from that day to nowadays, present day, lot of things have changed in the field of biomedical engineering. It is continuously very fast growing and fast developing area. And for the recent last 20-25 years, there has been a lot of tremendous contribution in the area of the artificial intelligence. So definitely when you want to apply the artificial intelligence, your intelligence will play a role above that. You will have to judiciously select your tools and judiciously select your program, judiciously write it, logically understand what is the requirement, how you are going to do it. So when we started from the machine learning, basic techniques. Nowadays, with the very fast growth in the area of your hardware side, particularly you are having very good access to the supercomputers, multi-core computers. Nowadays, easily up to 20 cores. Eight cores are very common. Even in your laptop, you are going to have 6 core to 8 core computing platforms. Then you are having very good resource in terms of GPU units, access to your supercomputers like Paramshiva we are having, and you can access it from here also. So that has really tremendously contributed. And one I can, we were discussing with the Professor Sinha yesterday, that in our institute, CDEC has installed that supercomputer, Paramshiva. And it is really very helpful in the students carrying out their work in the area of artificial intelligence and their application. Simply because the one main reason is that the biomedical data is big enough. You can consider it as a big data problem. When you are dealing with the MRI or CT scan, it is not a simple single scan. It is series of scans which has to be analyzed minutely and pinpointedly. What is the ailment, how the treatment is going on, what is the we can apply it to the treatment planning area. So lot many things are to just you can say that play around with this area of artificial intelligence and biomedical engineering. Simply because we are the population of almost 140 crores, and healthcare requirement over the worldwide is very, you can say that wide, and from the minutest thing to the big disease, you need these tools. Nowadays, you know, if you visit the hospital, any modern hospital you visit, you will find that lot of the automation is there, lot of AI applications will be there, and lot of instruments are there which directly rely On data assessment, it's analysis and then treatment planning and then delivery. So it has become an integral part. But of course, for doing all this, you have to judiciously apply your knowledge and your intelligence also to work on these problems. So with this, I thank the organizing committee. They have very well organized the event and they have taken very well care of us, and nice hospitality was rendered to us. So thank you all. Thanks very much. Thank you again.
So thank you, Professor Neeraj Sharma sir, for your inspiring word and presence here. And now we have honor to listening to our one more chief guest, Ma'am, who has joined us today to share their insights. So I would like to call Dr. Siru Sharma ma'am to come on a stage and share your view.
So first of all, I thank Dr. Anurag and the organizing committee, Professor Sinha, for inviting us, sharing our views, and having a good interaction with all the participants. The SERB is giving this opportunity to organize workshops, and the success of these workshops basically depends upon the participant and their like learning how much they want to learn from these workshop and how much they want to learn from the speaker. And I have a good experience while sharing my views, while having the discussion with all of you. And AI is now exactly now that sir had told that AI is basically a growing area, and it basically gives a wide scope to all disciplines, and the students from the all discipline, whether they belongs to electronics or computer or having the background from the biomedical engineering, all can use this AI tool for serving the nation, for taking care of this healthcare side. So, and ministry is also giving emphasis on developing the center of excellence for AI and its application in the healthcare. So I'm very much hopeful that all of you will must have gained something and some knowledge, and so that you can put that in your thesis work, in your research work, that will be helpful for finding you the ways for doing your research work. So again, I'm very thankful to Dr. Anurag for taking care of us and giving us this opportunity. Thank you and wish you all the best, all the participants. Thank you.
Thank you, Dr. Siru Sharma ma'am, for your insightful feedback and the thought and your presence here today. Our workshop has had a guidance force, a patron whose vision has made this event possible. I would like to invite Dr. Pradeep Kumar Sinha sir, the patron of this workshop, director and vice chancellor of IIIT NR Raipur, to share a few words with us. Sir, sir please.
Good afternoon, everyone. Honorable Chief Guests, Professor and Madam Sharma from IIT BHU. We have come to the concluding session of this very important technical deliberation. 7 days before actually standing here, I just talked about our expectations and expectations from the participants and why we have actually organized it. Very happy that the workshop went on successfully because of the cooperation of everyone. We do not actually attribute its success only to the people, the member of the research IIIT. Basically, the success of such events goes to the country. Okay, because we had experts, participants, the sponsors, everyone from across the country. And that's how academic institutes are built. Okay, we never actually, being in this part of the country, we never felt that there is a shortage of certain XYZ resource for building this institute. You know that we started only in 2015, and initially we were struggling to even have enough faculty to teach the courses that were actually to be taught in our education program. Okay, but we actually never felt the shortage because we started actually considering the entire academic community and the research community of the country, okay, as a resource of the country which can be leveraged by us. And today you can see Professor Sharma, Madam Sharma coming here, many other very senior faculty members with whom we already heard, interacted. Okay, they are not from this academic institute. Most of the speakers which you see, okay, they were other academic institutes. Okay, so you can imagine the academic and research community of the country is a very different type of breed. Okay, they believe in sharing. Okay, they believe in actually extending because they never consider that, oh, I'm part of IIT BHU only. So I will do whatever my academic institute requires. I've never found that during my entire course of activities being steered here. So whenever there was an issue of actually having faculty members, we requested, and I'm surprised everyone very willingly, yes, we are coming. Okay, yes, I will be there. Okay, for how many days? 1 month. Okay, 1 month is fine. Okay, only thing, these following things will have to be adjusted because I have my other commitments in my own institute or XYZ institute. Okay, so that is the type of willingness that the research and academic community has in the country. And why I'm telling, because I found that many of you are still a research scholar or going to actually get into research and academic domain. So please never think that your research or your activity gets restricted because of the resource. It gets restricted because of your thought process. Okay, you do not reach out. Okay, and then you feel I'm limited to this. Okay, I don't get this, I don't get that, and then you start blaming your director or whoever is taking care of your activities. You'll find that our faculty members never actually tell me anything. Okay, they on their own. For example, Dr. Anurag. Okay, he as the main coordinator of this workshop. Okay, he only discussed, sir, हम लोग ऐसा करना चाह रहे हैं. Okay, funding we will try to arrange from a funding agency. Okay, and faculty we will try to arrange from other academic institutions. I told fine. Okay, just only ensure that our own academic activities do not get disrupted considerably. Of course, there will be some disruption. Okay, because some of the faculty members will be attending, some of the faculty members will be delivering talk. Okay, and you can see everything was organized so nicely. Certainly, thanks goes to our HODs, our faculty members, and everyone actually contributed in some form or the other. Okay, for example, I was talking to Professor Neeraj Sharma yesterday. See, there is no direct flight, okay, from Banaras to Raipur. And I know there are many people who hesitate in actually detouring. Okay, there's a direct flight, they will agree, okay, मैं आज आ जाऊंगा, एक रात रुक के next day निकल जाऊँ. Okay, they don't have problem in that. But when there is no direct flight, Okay, you can imagine the effort or the willingness that they have. Okay, traveling to some other place, waiting there. वहाँ पे फ्लाइट डिले हो गई या कैंसिल हो गया या कुछ हो गया तो अदर प्रॉब्लम्स है. Okay, so in spite of all that, everyone actually willingly comes to help a new institute. It's a new institute. IIT BHU के comparison में BHU 100 साल पुराना. Okay, so कितना है सर? हाँ?
110 years.
110 years. So you can imagine someone associated with 110 years old institute will think your मेरे institute तो इतनी बड़ी है, इतना well सब कुछ है वहाँ. Okay, I can be self-contained and self-satisfied here, but no, they believe that our responsibility also is to help these type of new institutes, new researchers, new people, okay, who are coming up in our area. Biomedical engineering में अभी सर ने बताया, although it started several years ago, but it is still so nascent, okay, that all of you who have ventured into doing research into this area or to pursue your activities in research, let me tell you, there is still actually so much opportunity that we are falling short of good people and good researchers. Why I am telling this, let me share with you that because Professor shared that the Param system installed in BHU was actually commissioned by SEDA. Okay, now I was directly looking after the HPC, high performance computing activities, and directly I was heading the Param division. Okay, before coming here. And we were actually planning to collaborate with many this type of premier academic institutes to provide them the hardware and this type of facility to accelerate research in their respective domain. Okay, and believe me, there are many application areas of where such type of systems have been commissioned, not only biomedical engineering, but one of the areas that is bioinformatics is actually an area where no matter how fast system you build or how fast supercomputers you build, it will always actually fall short of the speed for biomedical applications, bioinformatics applications. We had a very strong division, bioinformatics division in CDAC, and fortunately, I was heading the bioinformatics division also, and the medical informatics. There were two separate divisions. Okay, so the bioinformatics was going to cell level and genomics and other things. The medical informatics was providing healthcare to the patients. Okay, dealing more in that. So fortunately, both divisions were with me. And let me tell you that we used to do a lot of genome sequencing, sequence analysis, or early detection of diseases, because disease is one thing where if you actually detect it a little early, it is curable. If you pass the threshold, okay, it will not be curable. Okay, because now it has come to a stage where you can't cure, you have to live with it. But if you actually detect it, so a lot of research goes on this HPC systems on early detection of diseases. Okay, and one of the areas where we were dealing was cancer research with Tata Memorial Cancer Research Center in Bombay. We used to have very close collaboration, and I used to frequently go, and Dr. Badwe was there. I don't know how many of you have interacted with him. So we used to continuously work towards early detection of cancer. Okay, because cancer is one thing where Dr. Badwe always used to say, सर अगर 10 दिन पहले या 1 महीने पहले भी पता चल जाएगा तो हम पेशेंट को बचा लेंगे, लेकिन वो अगर टाइम निकल गया तो फिर वो पेशेंट बचेगा नहीं. So that is the criticality, and still I'm telling it's not fully solved. Okay, for many diseases. No, I'm not telling about cancer. Okay, I actually am happy that such an important topic was dealt with in this workshop by the country. Of course, here in our campus, we are lucky that it happened in our campus. But I always consider it that it was done by the nation. Okay. And some of us actually only got the opportunity by God, okay, to do this. So we are lucky, okay, that God gave us this opportunity to do it in our campus for the benefit of all of you, for the benefit of the country. So let's take this forward. Okay, let's not stop it here. Okay, I have talked to Professor Sharma yesterday that whenever required, okay, we should collaborate and take things forward. Okay, possibly some of our students uh, can go for PhD under him. Okay, at IIT BHU. And many other different opportunities are there. I was telling that they go abroad. I told, why not to IIT BHU? Okay, when I have experts sitting just with us. Okay, so those type of opportunities are also developed because of this. And uh, let's take this opportunity to build a strong group in healthcare, AI in healthcare. Okay, you all should not actually just disintegrate from here. Make a group, WhatsApp group or whatever, okay, email group, and keep interacting. Okay, I'm doing this. Anyone has any clue of I'm facing this problem? Okay, can I come to your place to use some equipment which I don't have, like a supercomputer? Okay, which I don't have. Can I stay there for 1 week? These are possible. We have actually grown with this culture. Okay, all the best. Thank you once again, especially to our main coordinator, Dr. Anurag, the volunteers, okay, who got been naming everything, whom we just actually gave a token of appreciation in the form of certificate. That's not anything for the work they have done. 7 days they kept on looking after the logistics, travels, everything. It's not easy. Okay. Thank you, everyone. Thanks my own faculty members. Thanks, volunteers. And of course, thanks to all the participants and the speakers, okay, who came here to enrich and make this workshop successful. Thank you.
Thank you so much, sir, for your unwavering support and encouragement. And now, as we come to the end of this wonderful journey, it's time to express our heartfelt gratitude to all those who have been a part of this workshop. Now it's time to a vote of thanks. So may I request Professor Srinivatan KG, sir, Dean R&I, for a vote of thanks, sir. Sir, please.
Honorable Vice Chancellor, sir, distinguished guests, dear colleagues, and my dear participants. So at the outset, we are happy that the workshop has been concluded. We are also not very happy that our distinguished guests who have come here and have stayed here for so many days are now going back to their station. So this is the time, as he told, it is a vote of thanks. Let me first thank the whole and soul coordinator of this workshop, Dr. Anurag Singh, because it is his brainchild. He is working in this field from last 2 years, and he has produced 2 distinguished scholars in this area of AI and machine learning in healthcare. And he is working in this field from since long time, and it was his brainchild, and he has conceptualized this whole workshop, and he has applied for the funding agency. He successfully got the funding from SERB, and also added to that, we wanted to announce that he has also got a project from SERB in the same domain. And because of his continuous efforts since a long time, this has been conceived in a very well prepared manner, and congratulate him for successful completion. And anyway, I always tell, organizing such type of event in India is like arranging a marriage. Okay, so he will get night calls from the participant, मुझे थोड़ा जाना है, urgent certificate दे दो, certificate में नाम नहीं है. So, and he has to travel, मैं अभी 10 बजे आ रहा हूँ, gate खुलवा दो. See, he has to undergo all these pressures, but he has taken care everybody with due respect and due this one. So whatever the best thing that you are seeing, it is because of his effort. If you are seeing some of the disturbances, it is because of our mismanagement. So, okay, but he has tried his level best to accommodate everybody and place them in their comfort zone. So, first of all, thank him very much. And he has been ably supported by a student group from UG to PhD. So he has built up a good student factory who are working in this area. Again, you have a lot of UG and PhD students, and thanks to them for coordinating this event. And again, we have a moral support from the administration and the management. I thank one and all who is there in the ladder from who are working in this institute, who has directly or indirectly supported this institute. So thank you very much. Take away the sweet memories of the campus, especially the green campus, the Chhattisgarh as a state, and Raipur as a city. Take the sweet memories. Of course, you may not find some of the facilities as you see in the metropolitan cities, but still, in a life, you have to spend some time in these kind of places also. You might have enjoyed the nature in and around. So take away your sweet memory. Thank you one and all for your, as I always tell you, first of all, I thank all the distinguished speakers who have agreed to come and give the talk. Not to this, nowadays, getting a speaker is easy, but getting an audience is a very difficult. I have been told by DST in some occasions that many of the workshops are being cancelled due to lack of audience. So we are happy that because audience are uttama shrotru vrindaha, means unless and until there is no good audience, even the speaker gets bored. Okay, the value of this. So therefore, audience plays a very important role, and I find that all the audience are sitting for all the sessions without any, because in some places we see they will be there only for the time when the attendance sheet is circulated, and rest of the time they will go out. But here we have not seen any one of you coming out of the classroom. Really, it was a good experience, and thank you for your patience. And definitely, this will help you in your future. Thank you, Anand.
Okay. So thank you, sir, for your thanks of vote of thanks. In conclusion, this workshop has been a remarkable learning experience for all of us. It has brought together brilliant mind, forecasted collaboration, ignited a passion for AI and machine learning in healthcare. As we leave here today, let us carry forward the knowledge gained and the connection made to make the positive impact in our respective field. Thank you once again to everyone who has contributed to the success of this workshop. We look forward to the future endeavor and the continued pursuit of excellence in AI healthcare. Now I request all of you to please come for a group photograph. And after that, the height is outside, so you may take. I think come fast, otherwise it will going to take another 20 minutes. Come fast. Sir. आ जाओ
सर कवर नहीं सर कवर हो रहा है ठीक है ज़्यादा ऊपर
Thank you. Thank you.
हाँ सर